Hi, everyone, and welcome to SHIPPED23. I'm your host, John Bristow, and joining me is Gemma, who will be your co host. Hi, Gemma.
Hi.
This is really exciting. We've been looking forward to this event for months, and it's finally here. So, this is great. Gemma and I are going to be your hosts, and we're going to be walking you through basically all the things that you're going to be seeing today as part of SHIPPED23. We've got a bunch of presentations featuring a wide swath of technologies and deployment techniques. It's going to be a lot of fun. So, let's go ahead and kick things off by, through the magic of technology, this is our opening remarks. There we go. So if you need to reach us, you can do so through a variety of means. But this is Gemma and myself, and we are part of the community team. So if you see anything relative to community, whether it's our Slack channel or YouTube channel, whatever, chances are one of us is behind it. So there you go. You are watching this event through a platform that we have, and you'll be able to participate with others through the integrated chat. So feel free to pose your questions there. We have folks from a variety of teams at Octopus answering questions. We'll also have community members answering questions as well. So, take advantage of that as you go through it. Don't forget, we also have our videos up on YouTube. So Octopus Deploy is up on YouTube. We have a bunch of videos there, and we post all of our webinars. We post all kinds of interesting conversations that we have with customers there. We've posted a bunch of videos there, so feel free to take a look at our channel. This is at youtube.com/octopusdeploy. You can just search for Octopus Deploy on YouTube, and you'll find us there. Gemma, we have a lot of webinars as well, don't we?
Yes, we do. We have kicked these off this year, so we've covered, as you've just mentioned, a wide variety of topics. If there are webinar topics you haven't seen that you would like to see, please reach out and let us know. We'd be more than happy to cover them, and just keep tuned. We add more and more each week. So, yeah.
There's also our roadmap. This is a URL that I don't think many people know about, so I keep citing it all the time. This is at roadmap.octopus.com. If you're at all curious about some of the things that we're working on, or some of the things we may work on or are planning to work on, this is the one URL to rule them all. So roadmap.octopus.com. This should be your homepage. If it's not, make it a bookmark. But this is where we basically manage all kinds of items that we have for building on top of our existing platform. Our product team's there taking your feedback. You can also you can also send us your feedback for ideas if you so wish. And so go check that out at roadmap.octopus.com. And Gemma, we also have a prize draw at the end.
We sure do.
Fantastic. All right. So I thought it'd be good for us to go through the schedule for today's event. So our event's going to run for about 5 hours or so. So grab a bag of popcorn, sit back, relax, and let's take a look at some of the content we have scheduled. So Paul, who's our founder and CEO, will be kicking things off with his presentation entitled Accelerating Software Delivery at Scale, where he'll be telling us about where we've come from and where we're going. So Paul started Octopus Deploy way back when in 2012, and he'll be sharing with us the journey and where he thinks things are going relative to that. Colin's going to be presenting also. He's our SVP of product, and he'll be sharing with us detailed information about things that we've built into Octopus, as well as our roadmap. We also have some other things as well, Gemma, don't we? We have some interesting presentations following that.
Yes, we've got presentations from Ships from our product team, along with Alex Klinkenberg. They'll be talking about how we are planning to scale the Octopus Cloud and the plans for that. And then also hearing from Michael Richardson, who I was actually with last week, which was awesome. We were at GitHub Universe. So he will be talking about the real world, yikes, release pipelines with GitHub Actions and Octopus Deploy.
Following that up, we've got Kit and Robert, who are going to be talking to us about Kubernetes. As many folks know, we support Kubernetes as part of a deployment process for Octopus Deploy, and this is going beyond the sort of GitOps strategy that most folks have when deploying to Kubernetes. We also have Paul Grady, who's going to be talking a lot about performance. So one of the things that a lot of customers ask us about is, hey, what are you doing around performance with Octopus? Paul is right in the middle of this. So he's one of our software engineers who's doing a lot of work to help improve performance around Octopus, and I'm happy to reveal that Paul and others have done a lot of really cool things around this space. So Paul's going to reveal the sort of behind the music scene around what's happening at Octopus relative to performance. Awesome. So Gemma, tell us a little bit more about some of the sessions we have. We have Ian and Steve next.
Two great sessions, I am sure. So we've got Ian taking us with the new features for tenanted deployments. You will have heard a lot from us this quarter, especially about our tenanted deployments and how we handle those, making it super easy for you to view, manage, and administer your tenants at scale with Octopus. And then Steve will be taking us through the DORA, DevOps, and deployments and how they all link together.
Wrapping things up, we have the one and only Bob Walker, who's our field CTO here at Octopus Deploy, talking to us about multi-tenanted architecture lessons learned. So Bob's got a lot of past experience with this, and he'll be sharing some of the insights, and he'll be showing some of the battle scars and scar tissue that he's developed over the years, building out solutions for deploying to multiple tenants. So that's our schedule for Shipped 23. Now remember, don't forget, stay tuned to the end for our prize draw. So it pays to take advantage of the entire event, and we'll be drawing a random person for this. But until then, thank you for joining us. Thank you for your time and attention. Gemma and I are incredibly excited to have you here. And with that, we'd like to turn things over to Paul, who's the founder of CEO of Octopus, and tell us a little bit about accelerating software delivery at scale.
Hi everyone, I'm Paul Stovell, founder and CEO of Octopus Deploy. Welcome to Shipped 2023. We exist to help you ship software, and of course we ship software as well. And so this is a big celebration of shipping software and showing you all the things that we've been working on in 2023 and what the future has in store. My software career started in the early 2000s, and at that time there was this powerful movement around Agile. Instead of spending years designing and building software only to disappoint customers, Agile promised this new way of working. At the heart of Agile was this idea that by doing short iterations, delivering something valuable to the customer, getting their feedback, iterating on the feedback, that we would collaboratively build better software. Rather than software being something that's specified, it was going to be something that would be co-created in this ongoing conversation with the customer. This quote on screen is from the principles behind the Agile Manifesto in 2001. And to this day, I think it's still the best articulation of why software teams exist and what customers want from them. Now, if you look at this quote, it talks about two things: the continuous nature of delivering software and the value of the software. And I don't know about you, but value is really hard to get right. If you're a genius, maybe you come up to the perfect idea and you build it and you ship it and they love it. But for most of us, we start with this kernel of an idea that will be useful, and it gets hammered into shape in the furnace of customer feedback that comes with that. In my consulting days before I started Octopus, when I reflected on the projects that went well and the ones that didn't, it became obvious that the deployment process was this critical unblocker. Deployment is this magic moment where software goes from being an idea that works on your machine or a demo that people can and nod to something that they can hold for themselves, that they can use, that they can develop a real opinion about, and that they can give you feedback about, feedback that you can really action. On projects where we could deploy easily, we had these wonderful collaboration opportunities with customers, and they saw us as enablers on their journey. On projects where we couldn't deploy easily or it happened very infrequently, our relationship with the customer was always on this continuous decline. There were very few moments to put something in their hands, get real feedback from it, and iterate on it. At the time, this is back in sort of 2010, CI, source control, they were solved problems. We knew how to use source control, and we could check code into Git, and we could compile the code and run tests. And everyone thought that CI could do deployments. That's what we all did. There would be a deployment step and you would put your script there, and those scripts became big and unwieldy. And we started to realize that deployments are far more complex and far more important than CI systems were ever designed for. And that's where Octopus was born. We asked, what if a system was built to do CD from the ground up with deployments at the very heart? Deployment is where rubber meets the road. It's where you pass go and collect $100 of customer feedback. It's where works on my machine meets the reality of life in production, where the microservices that were built in chaotic isolation across teams suddenly need to be orchestrated together in a symphony. It's where you deliver 15 things, but you're only remembered for the one bug that you introduced. Deployments where all the enterprise red tape and concerns around risk and compliance wrap themselves around you and they try to hold you back. It's where the baton is passed between dev and ops and gets dropped sometimes along the way. It's where mission critical applications go down, users rage at you on social media, where there's no option to fail fast and all you can do is roll forward while everybody's watching you. It's the rocket launch where people are waiting and holding their breath to see if what you're delivering makes it or if everything bursts into flames. Deployment's the beating heart of how software teams continuously deliver valuable software, and it's the mission that Octopus was born from. And 10 years ago, it was a dream, but today nobody is doing what we do for the kind of scale and complex deployments that we do it. There's end-to-end DevOps platforms that have some basic deployment capability, but no vendor has as many talented people working solely on making complex, hard enterprise deployments at scale work as well as we do with the experience that we have. And for this, we owe a big thank you to all of you. You may know that Octopus was born as a bootstrap, profitable company. We're not heavily venture backed. And without you, we wouldn't be here. You've put your trust in us to handle our most complex deployments for your most mission critical systems in your most sensitive environments. And you've worked with us as we've iterated on our product and our business model. And we wouldn't be here without you. So thank you so much for being a customer. As you know, we focus on three core parts of the continuous delivery pipeline: release orchestration, deployment automation, and runbook or day two automation. And our ambition is to set the standard for those things. And that's it. We're not trying to do source control. You've solved that already. We're not trying to automate your builds or track your bugs or to build dashboards. You've got all of those. But deployments are complex. No one says don't check in code on Friday or don't update Jira on Friday, but they'll warn you about the consequence of deploying on Friday, and for good reason. And we go deep, whether it's virtual machines to cloud native, on-prem to cloud, supporting the most complex deployments rolling out across hundreds and thousands of retail stores. There's no other product that does what Octopus does. Deployments start simple and over time they grow in complexity. And we're the only product that takes that scale and complexity in its stride. And just as your applications and CI/CD pipelines are evolving, Octopus is evolving too. We see a lot of teams starting to focus not just on how do I build a tight CI/CD pipeline for each of my applications, but with this explosion of applications that we have, how do we do that in a way that scales, where we've got hundreds or thousands of applications to maintain, but we don't want to have to maintain hundreds of thousands of independent CI/CD pipelines. While at the same time, we have to accept that applications are different realities, the complexities of them, and so we need to be able to support that too. And so we're really focused on how do we enable platform teams to go about this right. There's a lot of tooling in the platform engineering space in particular that is very focused on generating stuff. And it works great on day one, but day two, that's a lot of stuff to maintain that's getting generated. And we're thinking long and hard and working actively on a roadmap that's going to make life a lot easier for platform teams trying to do CD at scale. So in 2023, was laying the foundation for this. You'll see in the sessions coming up a lot of talk and showing the things that we've been doing around Kubernetes in particular and enterprise GitOps. Kubernetes, of course, becoming very quickly the enterprise standard for compute, displacing virtual machines. The everything as code movement is a big part of the work that we've done this year, obviously around config as code, our Terraform providers, and a lot of other things that you'll see. And then tenanted deployment, something that Octopus is uniquely good at handling, but deploying to whether it's hundreds of retail stores, hospitals, hotels, any site where you've got physical brick and mortar locations, and that's what production deployments look like. Or if you're deploying SaaS applications where every customer gets their own infrastructure. This is something that Octopus uniquely models well. And we've been very focused this year on how do we do that at scale? How do we do that across not just hundreds of tenants, but thousands of them in the UX and the performance of it? And lastly, you're scaling and we're scaling with you. So how do we make Octopus Cloud the best place to run Octopus? How do we handle the kind of scale that you're running at? And how do we continue so that Octopus is taking your scale in its stride? Now, I'll end on this slide. We've got 5 values as a company, and one of them, they're inspired by the Agile Manifesto, is that we value listening to customers over following market trends. So what you're not going to see today is a whole lot of slides around how we're using AI to enable Octopus or other things that external people might be interested in, but you as a customer with real deployment problems to solve are perhaps a bit less interested in. The quote that I shared at the start around from the Agile Manifesto, our highest priority to satisfy the customer through the early and continuous delivery of valuable software, that applies to us too. Our highest priority is to satisfy you through the early and continuous delivery of valuable software. And so that's what we're here today. Shipped is a chance for us to show you what we've been working on and the work that goes behind it. It's a chance for you to share your feedback with us so we can complete the next iteration and continue to deliver valuable software to you.
Oh, hey, welcome to Shipped. I'm so glad you could join us, and I'm so excited to tell you a lot about what we've been working on here at Octopus Deploy. My name's Colin Bowen. I'm the SVP of Product. I support 110 Octonauts doing wonderful work that I'm happy to share with you today. Now, look, to get started, we are absolutely obsessed with helping you get to happy deployments. For us, it's really critical that we have a product that you can trust and love and know that it will work when you go to hit that deploy button, whether it's Sunday at 3 a.m., Tuesday at 4 p.m., or Wednesday at 9 a.m. We want to make sure that you've got deployments that are repeatable, reliable, and traceable. And so we were building all kinds of capabilities to take that to the next level. So know that this is absolutely a quality product piece that we care about. So a lot of what I'm sharing with you today is a result of the hard work that we're doing, working with customers like yourselves to build and support your deployments getting to the next level. As I mentioned, we are 110 Octonauts across Australia and New Zealand. We're getting back out into the community. It seems like this year we're at the customer conferences. We're at various developer and product management and design events. So we'd love to see you. If you ever see an Octonaut, we've got stickers. We'd love to say hi. We're a very friendly crew that would love to get to know you a whole lot more. So please do come say hi if you see us out in the community, whether it's at KubeCon or DevOps Enterprise Summit or at some of the local meetups. Um, all these features are driven by both that vision and passion to bring you happy deployments, but also from your feedback. We do read every comment that comes in, whether you fed back through a form inside the product, send share some thoughts with customer success or support or sales, or commenting online. We are all reading, and we do read every single thing. So thank you so much for our feedback. It gives us a lot of fuel knowing that people are enjoying the usage, but also we're happy to take as well the less perfect feedback, knowing and giving us signal as to areas that we still need to work on and polish. So please don't be shy. We will take every opportunity to read all of your feedback. It influences a lot of our thinking and product decisions and gives us signal as to where to focus next. Now, look, before we get started, I thought I'd set the scene, tell you a little bit about what's on our mind. What are the things that are kind of keeping us up at night? Because we think they might be keeping you potentially up at night. And then we'll get into a little bit about where we're investing and some of the great features we've shipped and some of the things that we're working on next. Now, it's probably no surprise to you that container apps are becoming a thing. And for where we are on the adoption curve, while Kubernetes has been around probably for 5 to 8 years now, we're kind of at that stage where we're now starting to take it really seriously as an industry. In a lot of ways, it was like kind of back when we were going from physical machines to virtual machines. The real big test I remember at the time was, can the database server run on a virtual machine? That was it. If you've solved for the database server a high I/O, a high resource demand compute, then I can trust virtual machines. And containers were hitting that kind of momentum where we're getting over a lot of the trust issues with containers. And there still are a few gnarly barriers yet. When we work with folks like Brendan Burns over at Microsoft, we talk a lot about hostile code inside containers. And so, but we think this is a space, though, in 5 years' time, if you're starting a new project, it's almost certainly going to be a container app. And we see a lot of customers today piloting or kind of early adopting, moving their first couple of applications in the enterprise space or in the smaller space. We see whole customers running serverless and containers. So container apps are here to stay. Kubernetes, certainly, while it's become the dominant API and interface, will it be around in 5 or 10 years? Probably, but there's still probably innovation kind of in and around the space. But the concept of packaging as containers, it's here. It's not going anywhere. The other concept that's been kind of interesting, probably around longer than containers, is the whole declarative configuration. And we're seeing this happen across developer tools and operations tools as well. Now, this is again not something new. We had this with Ansible way back when, Vagrant and Puppet back in the VM days. Now moving forward to Terraform, Pulumi, and Octopus as well with our config as code. What we think is really interesting about this is not that anybody's really excited to go and write some YAML by hand. Plenty of memes out there about why that's not necessarily the most enjoyable activity, but it's the actual codifying of that schema, that state, that workflow that unlocks a lot of the collaboration and workflow opportunities. So I can diff changes more holistically inside the places that I already live, or run audit and scanning and practices tools over the configuration. So again, another trend that kind of as a DevOps engineer or platform engineer or a developer, just starting to pay attention to is how much of my workflow is moving to the sort of declarative configuration world. And the final big trend, and this is the buzz all over the social channels at the moment, is platform engineering. It seems like only yesterday we were talking about DevOps engineers. Now we're talking about platform engineers, and like any good industry, we'll happily rename things over and over to keep it fresh. But really, at the end of the day, the underlying motivation continues to be there of we want to be able to organize our teams, empower them with really great practices, in part so they can go faster, but also in part so that we don't end up with more variation coming into the IT portfolio. And ultimately for your CIO, CTO, de-risking a bunch of the compliance and regulatory obligations they might have by having too much data spread out in too many different ways that now become painful to manage. So three really important trends. These are things kind of ticking in the back of our mind as we're doing a lot of our work across the features we build, but also the problems that we're looking at next. And we hope these are on your mind as well. So where are we focused? Kind of those 110 octonauts. Some of them are thinking about kind of the what's next and maybe some emerging problems, but a majority of us are really thinking about three big areas of investment. Number one, enterprise Kubernetes. We really think kind of, we're moving beyond proof of concept initial teams adopting, and we're seeing a lot of customers who want to roll out container-based apps, in particular on Kubernetes, across their organization. However, they're finding today they're still spending a lot of time gluing together a bunch of tools, and they might be little point tools that do little bits of the flow, but they're building a lot of scripting glue to hang it all together. And when you step back and look at kind of where they came from, maybe a team that might have been deploying to machines, it's like, well, I kind of had ITSM approvals, I had environments. Why are we reinventing it again? So we're looking at how we can bring a lot of the concepts that have existed in tech in IT for decades now, and really make sure that those kind of learned patterns and experiences of kind of the things that almost stay true regardless of the tech continue on, and ultimately make it really easy for those application teams to kind of get onboarded with the enterprise definition of how you want to use Kubernetes. So lots coming up in this space, lots of work happening in the space. We'll talk about some of the specifics soon. Um, the second big theme, kind of partly teeing off the declarative configuration, but really also a bit of a step change for us at Octopus, is really becoming more and more opinionated about using Git to store assets, or having Git store your workflows, or using those workflows like commits and pull requests and whatnot in the way that you interact. And so you're going to see a lot more across the Octopus experience with source controlled assets, in particular around Git, as well as some enhancements around GitHub itself and how we make that a great experience. Seeing a lot of interest and kind of people starting to kick the tires around GitHub Actions. We love the folks over at GitHub are chatting regularly with their product teams. We're just at GitHub Universe if you saw us there. So we think there's lots more happening in Git and GitHub coming in. We want to make sure those workflows are rock solid. And finally, we're thinking about those org scale portfolios, moving beyond kind of like I've got my tech stack set up for my new apps. Well, what about all those heritage apps? The 95% of the IT portfolio that was built over the last 20, 30 years. How do we bring that all together into that kind of single pane of glass, single set of kind of governance management controls? And also just generally, kind of go back to that Octopus promise of I can hand the deploy button to somebody and then I can see where my changes are. How do we fulfill that at an organizational level? So again, working down that path, and happy to show you some of the great things that we're working on there today. So let's start with enterprise Kubernetes. Now, if you haven't been paying attention for the last 2, 3 years, we've been starting to ship more and more Kubernetes related functionality. And in the last 12 months, I'm really happy to share with you just some of the bigger pieces we've been unlocking, and some even bigger pieces coming in the very near future. So first and foremost, Kubernetes tools, a lot of them are command line based. I may have to have multiple terminal windows open just to kind of get a sense of what's happening. But what the real change is I deploy a manifest that touches a bunch of objects inside this single action. And it may be important to really understand kind of, is there a replica set or a pod that is, for whatever reason, not spinning up, not taking on my deployment. And so we've actually gone and seen this pattern where we watch what people do and see what else they're doing around Octopus and the deployment with our customers today using Octopus with Kubernetes. And we're saying there's actually an opportunity here to bring some of that status of deployment back into the tool, give you the really essential information you need to understand if a deployment fails, where it might have failed, and what's gone wrong. So seeing a lot of adoption amongst our existing customers using Kubernetes of this feature, because it's just giving them more visibility, more power right within the deployment experience. As I mentioned, Git's a big part, but also in particular for Kubernetes, with the whole GitOps style of working, you want to be able to reference a lot more of things stored inside Git. Whereas previously with Octopus, we worked at kind of more from a package-based cycle, and so you'll start to now see opportunities to things like, for example, pull scripts or YAML manifest directly from Git. And this will make it a whole lot easier for you to both kind of reuse files across projects, but also save you a couple of extra steps in getting your deployments configured and rolling out. Customize. Now, lots of, as usual in the Kubernetes ecosystem, there's usually a couple of different ways of doing about the same thing. For us, we're taking a little bit of a bet on customize, and we see this tied together nicely with Octopus variables. And so we've built in a first class step that allows you to transform your configuration manifest using customize, and then connecting that obviously with Octopus variables to get that really multi-layered templating experience. Now, coming up, this is really exciting. There's a lot of things that we kind of figured out over the last kind of 10 plus years of deploying to machines around how to get workloads into places. And into places where it's in my data center, or maybe it's in somebody else's data center, maybe it's in a retail store, a hospital, all these different places. And one of the things that we've learned is that there's a couple of patterns here that have kind of stood the test of time. And the tentacle agent that is running in the place you're trying to deploy to unlocks a bunch of opportunities. So with Kubernetes, we're going to be shipping a Kubernetes tentacle so that you can deploy and run tasks right within the cluster. And you kind of get all the advantages of Kubernetes scaling. We simplify a lot of the cluster authentication, and maybe possibly remove the need for something like Argo in the mix. Maybe you don't need that to get your app out the door. But more importantly, we're doing it in a way where we're bringing all of that experience and deploying to bear here, and offering things like the polling mode, so you don't have to expose your Kubernetes API to networks that you may not trust or may not be able to expose with. So we're getting all that goodness, and of course, it'll be a single step install. We'll make it really, really easy. We'll make it just work as we have with our tentacle on machines. So really excited to hear how you might adopt this. And again, if you're interested in it, we'll tell you more about how to give us some feedback. The other piece that we're working on, again, kind of going back to that sourcing of YAML files and starting to notice some patterns, in particular as we see real world GitOps practices and what really matters. one of the things that we've identified is that release creation around Octopus, getting that triggered, whether it's a Helm chart update or a container image in a repository that changes, or maybe just in general a Git commit. How do we get that to kind of kick off the process, create more of that pull-centric practice? So you'll see us release a couple of triggers to trigger releases, and that should hopefully keep your deployment processes a little bit more simpler. And finally, in the Kubernetes space, we know that I still think we're in kind of day one of Kubernetes in so many ways. There's still a lot of teams out there that are just starting for the first time, or maybe the kind of innovator digital team has figured it out. Now it's time for the rest of the teams to adopt, and so we want to really make it easy for whether you're a new user or you're an experienced Kubernetes user to just get started with Octopus and Kubernetes. So we'll make that process a little bit simpler, learning from our 300 plus customers today doing Kubernetes with us, watching our newest customers now starting to adopt, and we'll incorporate some of that practice into the product experience. So definitely keep upgrading if you're using Kubernetes. There's lots of goodness coming in every single release. Now, in DevOps Enterprise Summit style, just to borrow something from that great conference, I want to share a little bit about where we need some help. So we would love to hear about anybody who's looking at how to monitor Kubernetes resources after that deployment execution happens. What happens next? What's the next 5 minutes, 5 hours, 5 days look like? Not and kind of give us a sense of what you're looking for, what signals, etc. We'd also love to talk, as I mentioned, kind of with onboarding, anybody who's onboarding application teams who are new to Kubernetes. So not your kind of expert team that's done the pilot and figured it out. It's the every other team that you want to bring into the mix. So if you could share some feedback, octopus.com/roadmap, you'll see a few cards. There's also submit new idea up in the upper right-hand corner. Give us some feedback about how you're solving some of these problems or how you work on this today. And of course, stay tuned. We've got a whole session here at Shipped on beyond GitOps and how we're applying some of those practices. So we'll share with you some of the things that we're learning and seeing out there. So that was all things Kubernetes. Now, of course, your whole IT portfolio, if you're in a large bank or government or whatnot, you're probably not all Kubernetes, but you're probably adopting much more declarative configuration and kind of Git-centric workflows. So this is something we think actually a lot of teams are already well and truly adopting, and so again, been working to make this a whole lot nicer and easier. So earlier this year, late last year, we shipped version control variables, so kind of extending the config as code to include the variable management. That was a really important thing that we heard from customers in terms of being able to manage that configuration. And we've included things like being able to scope those variables right within the process. So again, kind of an essential piece beyond the original config as code launch. We also shipped branch protection because nobody wants to accidentally commit to the main branch an unplanned change when they meant to commit it to a feature or a test branch. So giving you those controls to rest assured that you're not going to accidentally deploy something to production, or users won't be able to accidentally deploy changes to production when they're changing their configuration. And then if you haven't been following, we've been shipping a whole bunch of GitHub Actions, and this started last year and kind of continued into this year. And it's a comprehensive set of GitHub Actions, everything from pushing packages to triggering deployments and runbooks. And this is allowing for all our customers who are looking at, maybe it's time for a new CI tool and what's that handoff point look like, et cetera. So we really love what's happening over in GitHub Actions and been supporting it for the last 2 years. Most recently, we've improved. So if you kind of looked at our actions in the early days, it's gotten even better. We've flipped the switch from calling the CLI to using the API directly, and we're seeing a much faster workflow start and execution. So if you're using GitHub Actions, exploring GitHub Actions, build with Octopus, deploy with GitHub, or sorry, build with GitHub, deploy with Octopus. Where are my words? We'd love to help you with those complex deployment scenarios on top of GitHub Actions. And of course, security paramount these days. As things go to code, what we don't want to do is ask you to manage a bunch of API keys all over the place. So we'll be rolling out OpenID Connect, and really kind of focusing around that kind of initially Azure and GitHub connectivity to make sure that we can securely have that connection without having to manage yet more API keys and credentials around the system. So definitely take a look at that if you're using either of those services. And what's coming up in this space is a GitHub app. Because we certainly, while we've seen good adoption and good feedback on our GitHub Actions, there's more we want to do in this space. We've got lots of really great ideas we've been bubbling around with the GitHub Actions team over at GitHub, but it all starts with a GitHub app. So you'll see that first release coming out shortly. It's going to focus on a lot of the config as code project scenarios, but we'll be exploring more in the future there. So do keep an eye for that. We've been starting to use it internally in our deploy instance, and yeah, really loving what we get there. And it's of course spawning lots more ideas. So we're excited to bring this to you very, very soon. So what do we need in modern workflows? What are we listening for? Well, we're listening for, and we've gotten a lot of feedback, and so we're pretty, kind of confident we might do something in this space by getting those run books stored as code in a Git repository. But if this is you, and maybe you haven't heard of this, or maybe you haven't given us the feedback, please pop onto our roadmap and let us know. The other side is the Terraform provider. We've been doing some smaller enhancements around the Terraform provider, but we're seeing a lot more customers use it at scale. And so really want to hear from how you're using the Terraform provider today, maybe what challenges you're hitting and how you'd like to use it. But if you want to hear more about GitHub Actions and more modern workflows, stay tuned for the session coming up. All right, finally, I'd love to talk to you about some of the things we're doing to scale up kind of your usage of Octopus, really kind of get it ready to be that standard tool for the enterprise. So let's dig into it. So you might have noticed we're talking a lot about multi-tenancy lately, and actually it's been an area both of pride and evolution. It's been a feature that's been around for a while. It's used in particular to deploy to the edge or to deploy to multiple clouds and data centers. But what we're seeing though is actually an explosion of the numbers of tenants that people are using, and so it's causing us to think about kind of not just performance of the app, but the usability and how people interact. And so we've been spending a lot of time over the past 12 months really kind of talking to customers about how they're using tenants. And we've learned some things. It's not all quite retail stores. Some people have some very interesting scenarios. But what's come out of this is actually we've got some opportunities to improve the user experience. And it's something you've been telling us in the feedback. There are certainly some areas of the user experience that at scale start to get a little bit harder. So the redesigned tenants dashboard, if you haven't seen it, if you're a big multi-tenant user, I really encourage you to get the release and take a look at this. Not only have we made it rocket fast, we've been doing some fantastic performance engineering work behind the scenes. We've really looked at kind of how people use it, what information is necessary there, and how do you get views that make sense to you. So definitely take a look at that if you're using tenants. It'll also kind of give you a bit of a hint of some of the design patterns we're looking to bring to the rest of the application. The other thing that we're also recognizing is that when you have lots of tenants and perhaps you've adopted more microservices, so you got lots of projects. The last thing you want to do is kind of next, finish, next, finish. So we started to incorporate some bulk actions to really reduce the effort it requires to get things connected and configured. And so this is an example of the experience. Kind of again one of the patterns that we're testing out, where connecting projects and tenants is now a whole lot simpler. Instead of I think it was 5,000 steps to connect thousands of tenants and projects, it's now 5 easy steps. So we hope you appreciate this from saving you time. Also, kind of the performance experience of it just all happening under the covers, lightning fast. And a long time feature request. This one's been really kind of bubbling around for a while, so I'm really excited that we shipped this. But especially if you got multiple teams deploying all the time, occasionally you have this emergency that needs to get out the door now. And it might be a case of a configuration change, a piece of code, a runbook task that needs to run. And you can't, the thing you want it to do is just be the next thing that's run. So we've now introduced an ability to reprioritize the task queue, moving that critical task up to be run next. So really looking forward to the feedback on this one. This one's been a piece of feedback that people have been looking for for a while, and more importantly, we're seeing as in particular, it's becoming a real pain point as people do, thousands of deployments in a time period. Another one of those kind of quality of life things, and again, as you scale, is occasionally a task or a step gets stuck, and it might just need another go. And it could be a table lock in a SQL database updating. It could be, kind of a file in use. And so we've created this pair of step timeouts and retries. I'm really excited by how the team has done this. They've tried not to make it overly complicated. And they've made it up as kind of two individual features that you can use separate, but you can also pair up. And what we're seeing as our customers have been adopting this is actually it's really reduced a lot of those kind of hung and failed deployments, as well as the manual intervention sometimes to give things a nudge by saying, hey, you know what, this step along the way, why don't you retry it 3 times before you officially call it failed? And guess what? It's time 2 or time 3, it works. So again, another one of those real quality of life things that kind of give you time back in the day to focus on doing other things that move your application forward. And along the same lines, networks also can be equally finicky, especially if you're deploying halfway around the world, or you're deploying out into kind of rural parts where maybe connectivity sometimes is a little bit up and down. Here in New Zealand, you might be deploying to the middle of the South Island, where fixed wireless is your only way to get there, and occasionally a sheep walks in front of the transmitter. And so now you need to be able to just immediately kind of pick up where you left off. And so Tentacle now is a lot more resilient towards those network errors, and will reconnect and rerun and get you away from those deployments that may otherwise have failed. So really exciting if you're deploying to networks you don't control, or networks that maybe are a little bit shaky from a reliability perspective. A really, really great kind of improvement for you. And then, as I mentioned, new users coming into Octopus with Kubernetes. It's not just about Kubernetes, it's about new users in general. There's a lot of things inside Octopus, and we want to make it really easy, not just that blank slate of file new project, and then you've got to figure out where to go, but actually to guide you through the project setup. So if you've installed a more recent version, or you're on our cloud instance, you'll notice the new project experience is a lot richer now. But one of the really neat things here is both the sample step and the sample project. These are fully working kind of examples that you can insert to get that hands-on learning of key concepts. Because as us kind of developers out there, we like to get hands-on, get that bash script or that PowerShell script stood up, run a few things, make sure the connectivity actually works as I expected, etc. So we see this as a real enabler for those folks that are just kind of getting started with Octopus. So really excited to bring this to you. Really easy to add and get engaged with. But there's more. We know we've got some steps as we were doing that work on improving the guide and the setup. We see some opportunities to actually make it even less effort to get things set up. You might need to add credentials, accounts, feeds, certificates, all those sorts of things. Today, some of those experiences will navigate you away from the project context. So we're working on things to keep you inside the context, give you a sidebar with more useful information, more contextually relevant information if you're new. So keep an eye on this space. It's going to get a whole lot easier and a whole lot faster to spin up new projects on Octopus soon. So where would we love to hear from you on? I'd love to hear if you've got in particular challenges using the project tenant variables dashboard. Again, from a UX perspective, we'd love to see the real world and the gnarly combinations out there. So if you're using that, we'd love to hear from you. We'd also love to hear if you've got deployments or runbooks that need to survive maintenance operations, restarting a Tentacle, restarting Octopus server. We'd love to hear about those scenarios. We'd also love to know if you're really looking to increase the throughput of your deployments. We've got some ideas, and we've got some big architectural changes underway that you'll start to see in the product blog over the next couple of months, where we talk about some of the things that we're doing to improve that there. And finally, if your organization uses deployment freezes, something that might be relevant this time of year as people go away for holidays, we'd love to hear from you. So please reach out on the roadmap, send us your feedback, and of course, stay tuned to some great sessions for some more in-depth stories of these problem sets. So it's not just great product we want to bring you. We're constantly researching, working with customers, listening to the state of the ecosystem. One of the things that really is kind of my pride of Octopus is it's a product solving real world problems. And so we want to share some of the things that we're learning with you. So here are just three of many resources that we've shipped recently or will be shipping soon. You can get an early access preview of things that we're working on that are sharing a bit of that picture that we're seeing as we're talking to customers. And these are just real world things. We're not trying to sell you anything. We're trying to just give you that insight to help you make better decisions in your teams. And we'd love your feedback on them as well. So please check them out and let us know what you think. You can hear some stories of what we're learning, what we're seeing out in the real world in a few of the sessions coming ahead here on Shipped. So that about wraps it up. We've shipped a bunch of really big things. It's not all. There's lots of little things. There's lots of little performance changes. One of our engineering teams showed me there's a showcase from one of our engineering teams engineers that showed me where they took a view that was taking minutes down to milliseconds. So there's lots of little things happening. So if you haven't checked out the latest of what's new in Octopus, kind of at a broad level or in the change log, if you're, I definitely encourage you to take a look at getting to the latest. If upgrading's a pain, we've got Octopus Cloud. We're running some really big gnarly customers on Octopus Cloud, so we can always offload that keeping current pain and bring it into our cloud as well. So give us a call if that's a better option for you. And then, of course, the what's next. So here's the slide that you can share with all the other Octopus users in your company about really interesting things coming up. But also encourage you to take a look at our roadmap and let us know what else we're missing. What are we not working on that's really important to you? Again, we read all your feedback. We absolutely love it. So that's it. I'm Colin Bowen. On behalf of all of the Octonauts and R&D in Australia, New Zealand, and all Octonauts worldwide, looking to bring you happy deployments, which result in happy software teams, which allow you to do amazing things. Thank you for joining us today here at Shipped, and look forward to seeing you out in the field and meeting you over the next year.
Hi everyone, I'm Ships.
And I'm Alex.
And today we're here to share our story of how we've been scaling Octopus Cloud to meet the needs of modern application and platform teams. Today, we're going to take you through a journey that we at Octopus have been through over the last several years. You'll hear about our victories, our losses, our joyous moments, our painful ones. We'll also dive deep into the depths hitting the network layer, but you'll also see what the 100-foot view looks like for the future of Octopus Cloud. And I hope you're as excited as I am to be here today. So, like any good movie, let's start by setting the scene. Go grab your popcorn. Over the past decade, developer tools have gone from being these hand-rolled, fragile scripts to precious in-house custom software to now hiring third-party tools to do the same jobs. Today, we find there's a tool for every imaginable developer pain point, right? And there's a new one coming out every day. At the same time, the software we produce and maintain has multiplied. And this is due to our move from monolithic to microservices architectures, from highly coupled generalist software to specialized decoupled components, from standard tech stacks to great developer autonomy, right? And all in the name of innovation and growing and staying ahead. This means that in our world as engineers, we have gone from this, a very simple web services based architecture, right? Who remembers that? To this, a complex microservices architecture. And so, as complexity has increased tenfold, so has our cost to operate and maintain it all. Now, alongside all of this, the way we deploy our software has changed too. We've adopted best practices around continuous delivery. We've gone from a few deploys a year to hundreds or many deploys a day. And where we used to be able to wait a weekend or overnight to deploy something and then come test our stuff, today we expect to wait only a few minutes. We're noticing all of these trends are also influencing our developers' preferences and behaviors. We find that our customers are choosing cloud as they're becoming more and more comfortable with others hosting part of their ecosystem and managing it. Customers are choosing to lower that operational burden, and they would rather focus on adding value for their own products and not managing third party and supporting tools. SaaS products have been on the rise for many years now, and so the DevOps space is just really no different. And Octopus customers are opting for a cloud offering or migrating to cloud so that they can lower their operational burden. And we've seen this for customers even from regulated industries like banking, healthcare, insurance doing this. And so today, as software engineers and IT operators, we want to deploy more things more often. And this means that the demand on deployment tools such as Octopus has grown significantly. Now, 10 years ago, when we first built Octopus, it was built for making that few deploys a year seamless. But today, it needs to handle deploying on demand many times a day. And this is why it's become super clear to us that scaling Octopus to meet the needs of our customers is going to be critical. Over the last few years, we've invested a lot in our cloud offering and continuing to double down on that investment going forward. We have a team of highly experienced engineers and skilled engineers supporting Octopus and continuously improving it. What that means for you is that you don't have to worry about performance, uptime, scalability. We monitor, respond to issues 24/7, ensuring high uptime and minimizing time to recovery. We have a robust set of tools and process and practices internally to mitigate and manage all of this. We worry about governance, security, and compliance, so you can fully trust us. We're ISO and SOC 2 certified and regularly pass external audits with lots of praise. We ensure that our customer instances are isolated, especially that customer instances, data, and their file storage is kept separate. And lastly, we ensure that our end users get access to the latest features and quality of life improvements continuously. And so you don't have to wait for months or quarters for an ops team to go upgrade Octopus to get the benefits of our continuous delivery of our features. Now, all of this means that our customers have been able to enable their own IT teams to increase value and add that value back into their core services and products. Now, along the way, we've actually had to grapple with some many hard choices. Being a small company and operating like a startup meant that we had to make some very careful trade-offs. So, for example, when we first decided to build an Octopus Cloud offering, we really just wanted to test the demand for it, prove that our customers were actually ready, the market was ready for it. So we decided to simply take our self-host product, make a few tweaks, and then started hosting it in a managed VM. Now, as demand grew, we have now containerized our product, but at the same time have maintained those hard customer boundaries so that customer instances have little to do with each other and have little reliance on any shared infrastructure or libraries. And we're always looking towards the future to understand best practices and bring those in as we learn more and more, as the industry is learning more and more in terms of container and Kubernetes isolations. So again, when we built Octopus 10 years ago, there was no pagination. Processes ran on a single thread in a linear sequence. We used JSON objects to store data instead of relational databases. We opted for asynchronous communication protocols over synchronous, and we just assumed everything was always available and always online. There were many such choices we made that helped us ship just enough to meet the needs of our customers at that time, but also left heaps of room to learn, pivot, improve, and grow. Now, another significant choice that we made was to embrace the monolith when everyone else was embracing the microservices world. And as Octopus has matured over the last few years, we've been methodically scaling and rebuilding pieces to ensure that parts of our monolith can scale to meet the needs of our customers. And a lot of our customers have grown with us from a small business to being a really big, large corporate customer.
Yes. So let's dig into that decision that Ships talked about, the microservices versus monolith one, because it's a complex one and it's never an easy decision. So here at Octopus Deploy, we've decided to embrace our majestic monolith. And there are a few reasons for that choice. In my view, microservices versus monolith is not a purely technical choice. It is an organizational one. And this is because many of the benefits of microservices are organizational. In particular, they give you the ability to parallelize streams of work, to make changes in one area without impacting others, at least not directly, and to give developers inside the team unit that autonomy that they really crave. For us here at Octopus, we aren't so big that we really need to support that kind of scale. And so we've chosen to embrace the majestic monolith. There are a few key benefits to this. For example, the productivity improvements we make, that when we improve the monolith, they apply to all of our developers immediately. The other really awesome thing is that when we are investing in ensuring that our monolith is scalable and performant, customers see that impact immediately. Another really great benefit of the monolith is that it enables that single tenant cloud infrastructure that Ships was talking about before. It gives us this isolation by default. It gives us an expectation of a single resource. And so for us, it's really enabling all of the beautiful security things that we want to get for our customers by default. So we've been making some wonderful improvements to our majestic monolith, done by our productive engineering team, or PET. Some of these have included a massive migration from Nancy FX to MVC framework. For those who have no idea what that means, inside whatever application you're building, there's generally a web framework that you use to manage your API endpoints. For those familiar with the .NET world, you're probably familiar with MVC framework. It's pretty much the incumbent framework here. But when Octopus started, Nancy FX was a pretty strong competitor, and we went with them. And over the last 10 years, we've found that as our needs have changed and evolved, MVC is the right choice for us. This is a big, complex migration though, and it takes a lot of work to actually pull things like this all the way over the line. And this is why I'm showing you this amazing burn down chart. I found this tweet while I was looking at what we'd said about it. And yeah, this chart burns down. Do you see how we finished 3 weeks early? It is amazing. And so this is an example of the kind of work that the productive engineering team does that ensures that there is a standard way for developers to contribute so that we don't have the overhead of trying to figure out how to do things that are our bread and butter, and that everything is idiomatic. There is a really clear expected way to do things. So the team have been doing some other really amazing improvements as well. They're currently focused on our persistence layer. A while back, we built this full table cache, basically. It allowed us to query against a decently sized data set in a case where we didn't necessarily care about how fresh the data was. We made it super easy to use, and unfortunately we found that sometimes we were using it by default in places where it was actually hurting our performance instead of improving it. This is another example of work that doesn't really tie beautifully to a particular feature that our productive engineering team were able to knock out of the park and get those really great performance improvements in your hands quickly. Still in the persistence layer, you may all have heard of Nevermore. There is a wonderful blog post. It is a great story. I highly recommend you read it, written by Paul, our CEO. We initially started out with a document database, as Ships referred to, those JSON objects. That allowed us to prototype quickly without really having to tie ourselves to things like database migrations. Over time, we found that we do need more of the structure of the relational database. But in between there, we have written our own ORM. And ORM stands for Object Relational Mapper. What it really means is it's the bit of software that sits inside your application that helps translate the data in the database into the models for your application and helps your application understand how to communicate with the database. So we built one called Nevermore, and we have found that similar to the Nancy FX migration, we want to move into the incumbent one, Entity Framework, which is developed by Microsoft, much like MVC. And so we started dipping our toes in that water. I, for one, am very excited about it. And as part of this work to also improve our database, we're looking at normalizing out some of those tables that are currently treated like a document store to give us all of the goodness and constraints good constraints of relational databases. Work like this takes a huge team. And so I wanted to show you this kind of adorable slide with these nicknames, because at Octopus, we think it's really important that we acknowledge some of this work that might go unseen, that might be seen as unglamorous. And so we always make sure that we are shouting out our amazing people who are doing this important stuff. We have also been working very hard on some more customer-facing improvements. You'll hear a little bit more about this work from Paul Grady later on. So let me just touch on a few of the fantastic improvements that we've made. We've historically only had a REST-style API. A REST-style API is essentially modeled around a particular object and operations on that object. And we did this for a few reasons, but primarily because we wanted to make sure that we were investing in a great API experience. For us, internally developing our front end against this API, and for you as customers being able to use this API, it's a must in a developer tool. But as we've grown, at a very abstract level, just the count of objects that we are dealing with has gone up several orders of magnitude. And we're finding that that REST API just isn't really serving our needs. So we have been making a BFF API. I am skipping ahead a little bit, apologies. So what I'm playing for you now is this wonderful video that someone in our team did to show some of the benefits that we have gotten from moving to BFF. Despite what you might think, BFF does not stand for Best Friends Forever. It stands for Backends for Frontends. The idea is essentially that as an API, it will allow the developer to construct an API endpoint that has the data they need, whether that's across multiple objects, and only that data, which allows us to make it really performant. And so using this BFF, we are seeing these wonderful improvements. You might be looking at this and going, 5 minutes, that is nuts. But 24 seconds is still quite a bit of time. That is 24 seconds to generate a deployment. And I'm going to go in depth on the complexity of that operation a little bit later on. But we are so excited to see these amazing improvements. In particular, they're on our view release and create deployment pages. They are loading 12 times faster, guys. Those are big numbers. Those are some pretty big numbers. So we've been streamlining our deploy or release workflow. This is a 2 times improvement. As Sean said here, it is blazing fast. We've also made improvements to our tenants page and adding pagination. So as our customers grow, as you are adding customers, adding more tenants, adding more products to your deployment suite, we are growing with you and supporting your scale. And our customers are actually noticing it too. Remember how I said when we're investing in that foundation layer, you get the improvements already? We are getting some amazing feedback. I personally believe that recommended it to someone at like a neighborhood barbecue is an extremely high badge of honor. I don't think I've done that. So yeah, we love that you're enjoying it. Some of our bigger customers, like DriveCentric, are finding that Octopus is just scaling with them as they grow. And so it's super amazing seeing that we're able to help here with our amazing customers.
Awesome. So Alex has taken us through the main narrative of the movie. She's told us about some of the high points, some of the low points, our challenges, and more recently, our celebrations. Now, let me take you through a couple of bloopers that we completely edited out of our movie so far. Firstly, in 2019, like I mentioned earlier, we wanted to test our MVP for Octopus Cloud. So we did the simplest thing possible. We took our self-hosted Octopus server product and put it onto an EC2 instance for each customer that signed up for a cloud trial. We were spending over $100 per month to keep a single Octopus Cloud instance online, and that added up pretty quickly as trials grew exponentially. So we ended up footing a bill of $100,000 of USD monthly on AWS, with very or almost no revenue to offset that expense. And so 2 months after our MVP testing, we had to really accelerate building our Octopus Cloud V2 and push that out ASAP. Next up, in April 2021, Octopus Cloud was attacked by crypto miners. They created thousands of instances, and within a couple of days, we went from 2,000 active cloud instances to 5,000 instances. And so, I mean, we had no trouble in terms of customer impact. Octopus Cloud scaled beautifully, no worries, right? But we just had to pay hundreds of thousands of dollars again for the additional resources being used by the miners. So, as we know, no good movie can be shot in one take. So here at Octopus, we're always learning from our mistakes and iterating on our product to make it better. Now, let me take you to the behind the scenes to understand the depth of technical wizardry it takes to scale something like Octopus. So, what does scaling of Octopus on cloud look like? This year, we've been investing in vertical scaling for Octopus Cloud. We've made some improvements to increase efficiency of deployments and remove bottlenecks. For example, we've adopted better methods of communicating between server and Tentacle, and these changes have led to a better deployment throughput with reduced failures.
We've made a single instance of Octopus Server more effective. And this is fantastic because it means whether you are self-hosted, running it yourself, or using our cloud, you get to see these improvements. So let's dig into those a little bit. I'm going to start with one that we call async halibut. When we built Octopus 10 years ago, we built our own custom RPC protocol to communicate with our deployment targets. And let me back up for a second to orient you in what we're talking. So when you're imagining Octopus Server is our main application. You can imagine it like the head of the octopus. When we're deploying to your infrastructure, we call those deployment targets. And we run a little agent on those targets called Tentacle. Because get it, it's like the octopus and the little tentacles and your infrastructure. So we've got octopus and we've got tentacles. When we communicate between those two, particularly for deployments, we built our custom communication protocol and we called it Halibut. Octopus loves a good fish-themed name. So Halibut is an RPC protocol. RPC stands for Remote Procedure Call. Essentially, it just means it's a fairly efficient way of machine-to-machine communications. So when we built Halibut, asynchronous methods in C# had been released 5 months ago. It was back then, back in the day. We didn't use asynchronous methods in Halibut. It was 5 months old. Would you have trusted that in your production infrastructure? Would you have trusted it in your customers' production infrastructure? And so far, we haven't really seen too much pain with that decision. Now, as we were scaling, we found that some customers were hitting problems with their thread pool. And what was happening was while Octopus Server, so over here, happily working asynchronously, doing things in parallel, we were not necessarily able to operate asynchronously in Halibut, communicating to the Tentacle. And so this meant that Halibut would block the threads. And if we had too many going on, we might end up with thread pool exhaustion, which, just take it from me, it's a bad thing. We don't want to do that. So to fix this, we have moved to async. And I suspect a lot of you right now are thinking, what about the performance improvements? One of the benefits of asynchronous programming is that it just allows you to do more things while you're waiting for little things. The thing is, in the Octopus Server world, the operations we're doing, communicating with the Tentacle, network calls, these tend to be orders of magnitude longer than any sort of benefits that we gain from slightly higher CPU utilization. And so we don't necessarily expect things to complete more quickly, because you're not even going to notice the difference on top of all the network calls we're doing, but it will be more effective, and importantly, it's going to be more robust. And we are now using it in production. So that is pretty exciting. We have also been kicking ass, if I do say so myself, in our improvements around our reliability. Network instability is a fact of life. So while many of our customers run in cloud environments, and we have some sort of, guarantees around the stability of those environments, a lot of our customers are actually deploying to real-world devices. So that might be things like medical devices, portable devices used in hospitality, or even car washes. So the network constraints in those operating environments means that we can't count on high bandwidth or good connectivity. But it's important to us, and it's important to you, that Octopus still performs well over those conditions, and it's still able to robustly communicate with these remote targets. So another thing that we've done to our Tentacle and server communications in Halibut is that we have added network retries. And it's not quite as simple as, just adding if the network call failed, try again. There's a little bit more complexity in here. We've done this down in our custom communication protocol in Halibut at that layer, where we identify and detect network issues, and those we retry. We have a default 2.5-minute period over which we will retry, and a lot of the times we do see that those network errors resolve themselves. For other errors that aren't communication ones, we continue to pass those on up to the application to handle as usual. So this sort of retry at the network level gives us so much more robustness, and the best part is it is super configurable. So you can already use this. You can turn it on if you want. You can configure it to work the way that you want. We've seen some amazing stats with this. 7 days, 150 deployments that would have otherwise failed. We are loving the impact of this, and it's been a wonderful success. And the one thing to note is that when we are retrying network calls, we had to make Tentacle idempotent. And all that really means, fancy words to say, if we, ran an operation twice, for example, we retried a call and maybe accidentally ran it twice, idempotency means that it won't change the outcome. It won't do it twice. The outcome will be the same. So because we had to change Tentacle, the little guy that lives over on your infrastructure, to get the real benefit of this, you need to update Tentacle. So go on ahead to update Tentacle to take advantage of the shiny new reliability features. While we're here, while we're thinking about retries, we have also improved our step execution by adding retries. The cause of failures in step execution is quite different from Tentacle. It's not so much network related, it's actually often a human error, and it's very transient. And so what we've done is we've added an automatic retry, and we've added timeouts so that we can fail a little bit faster and then hopefully retry and succeed. So overall, we're just really digging into the many ways that our complex software interacts with the real world, with your infrastructure, and we're adding robustness where we can in a really targeted way to make Octopus Server as a whole more performant and reliable.
I hope you've enjoyed our story so far. So the movie for this year has almost wrapped up, but let's take a look at the new and exciting trailer for the sequel of the movie. Let me tell you what we have in store for Octopus Cloud next up. We're investing in horizontal scaling for Octopus Cloud, and our goal is to enable Octopus Cloud to scale to tens of thousands of deployments and runbooks, executing without breaking a sweat. This is going to be a game changer for both our new and existing customers. We would also love to ensure that maintenance becomes a non-event, and our customers like yourself don't actually have to plan deployments around it. Like any SaaS tool, we need maintenance, and we give you the flexibility to choose when suits you. Our routine upgrade maintenance, although it only takes 1 to 2 minutes, but we actually have to shut down Octopus Server to do this. So deployments just get lost when we shut that down, and they don't recover. We don't like how that works today, and so we really want all of your deployments to be happy ones, regardless of maintenance operations running in the background.
So to meet those really elastic, scalable, and high throughput goals, we need to be able to run multiple instances of Octopus Server in parallel. Octopus Server was not originally designed to scale horizontally, and so as Ship said, most deployments will not survive a restart. So let's walk through a few of the choices that we made in the early days and how we're iterating on them now. Software like Octopus Server is a bit different from most of the software that I've worked on before. A lot of web applications are very user-centric. What they're doing is responding to user interaction and requests. Typical sort of CRUD style, create, read, update, delete operations. Octopus Server is much more in the background. And, it does its most magnificent work when it kicks off a deployment. And ideally, you shouldn't even necessarily need a human in the loop for that. You can imagine that kicking off a deployment is kind of bursty work, right? Like you're, deploying out to this many environments, this many tenants, this many different things. And so there's a lot to do, and it all sort of happens at once we kick off the deployment. So to kind of manage that, to make sure that we don't hit resource exhaustion and that we're, utilizing our resources carefully, Octopus Server internally uses some building blocks of our application to enable developers to think about this in a really structured way and make sure that we're not going to get weird interactions. So one of these things we call a server task. That's really just a name for a wrapper for an arbitrary bit of work that Octopus Server might do. And that bit of work might be something like downloading a package. It might be running a health check. And it might even be calculating whether we need to clean up any old unused packages. So we wrap it all up in the server task abstraction, which makes it easy for our devs to reason about how that arbitrary work is going to be executed, how it's going to be queued, and how we're going to control how many things we're trying to do at once. I suspect you've been squinting at this diagram. The reason that I put it up here isn't necessarily to try to illustrate my point. I just want to talk about the complexity. So this is essentially what's happening when we are executing an action, when we are doing a thing. And as you can see, there are lots of different ways we can do it and lots of different steps. And the thing with a complex application that is built to flexibly deal with whatever customer scenario we need, with the intention of keeping it as simple for the user as possible, but also configurable, means that hopefully what you see on the front end is fairly polished and configurable where you need it to be. And we pay the cost of that in the complexity of the back end. So this means that our deployment execution pipeline, the way we create and run deployments, is a big complex engine, and making changes to it is pretty delicate. So we do it really carefully and deliberately. This here is the closest approximation we have to our deployment execution pipeline. When we first built Octopus Server, all of this, the deployment execution pipeline, was in memory. What that means is that an application, when it's running, in this case Octopus Server, its working space is what we call the memory. That's where it's doing all the stuff. The thing about that memory is that it's not persisted. As soon as the application shuts down, whether that's deliberately or accidentally, anything that it was doing in memory is lost. To save these things, you need to persist them. So since then, we have built what we call Octopus Server High Availability Mode, HA mode, to allow our customers to run multiple instances of Octopus Server to scale out horizontally so that they can do more work at once. And in order to do that, we had to persist our server tasks into our database so that both of those nodes, or however many nodes you run, can access them from that shared database and execute in parallel. This is pretty awesome, right? You can run this on your self-hosted infrastructure if you would like. It's gotten us pretty far, but we had that key problem to solve. We expected our Octopus Server nodes to be long-lived when we built HA mode. The way that we would spin one down was by draining it, meaning that as it was doing work, as requests were coming in, we would take it out of the pool of nodes that could get work, and when it had finally completed anything it had in flight, we would take it down. This process wasn't as robust as we would want it to be. It didn't recover from failure very well. And so to do that, we needed to rebuild parts of our deployment execution pipeline in order to give us that robustness. We want it to work the way modern containerized applications do, elastic, scalable. And so to do this, we needed to move from thinking of our Octopus Server nodes as pets into thinking of them like cattle. And so I show you these diagrams to explain that it is a really complex process for us to tweak these things. Especially, you see over here in this diagram, in the blue box, we can have arbitrarily deep levels of nested tasks, and we will dynamically change those on the fly or add or remove them as we're handling all of the complexities of a real-world deployment. And we now do that. This is super exciting. I'm really hype about this because it's something that my team has been doing. So what we've done is it's not quite ready for customers just yet. We have proven that our proof of concept that we wanted to build works. So we have a walking skeleton, which is just our way of ensuring that what we want to build is going to solve the problem the way we think it will. So from here, we're going to be building out from here. We're going to be supporting all of the complex scenarios that our customers need to do their deployments the way they want to do it. So we'll be adding more and more of this stuff, and keep an eye out for this amazing new functionality coming to you at a point that I am not actually allowed to disclose. So thank you all so much for this, lightning review of a huge swathe of work that we've been doing. We're all really, really excited about what we're building. We hope what you are. We hope that you are too. And don't worry about sticking around after the credits. There is no Marvel-style cutscene, I promise. This is it. Thank you all.
Hey everyone, welcome back. We are going to take a short 10-minute break, so grab a snack, grab a drink, get yourself comfy, and then we will see you back in 10 minutes for the rest of Shipped.
Hello, everyone. My name is Michael Richardson. I'm a product director here at Octopus. I joined Octopus back in 2015 as an engineer, and I have spent the last 8 years thinking about release pipelines. And the world of release pipelines has changed a lot in that time, so I still feel like I know nothing, which is a depressing thought. But today, we're going to talk about real-world release pipelines with GitHub Actions and Octopus Deploy. So the inspiration for this presentation comes from the fact that we've been working a lot with GitHub Actions recently, figuring out how we can make sure that Octopus integrates seamlessly with them and that it complements GitHub Actions really nicely. And what we realized while we were doing this is that there are hundreds of blog posts and plenty of guidance for creating simple CI/CD workflows. What there's not a lot of resources available for is the type of problems that you hit when real world organizations start to model their release pipelines. And we think we can help because if there's one thing we do at Octopus, it's spend a lot of time talking to our customers and other folks in the industry as well about their challenges in modeling these release pipelines. I've said the word release pipelines a lot. So with that, what we're going to do today is to dive in and take a look at what some of those problems are, these real world problems that people hit. And we're going to see, using a demo application, how we might model them using a combination of GitHub Actions and Octopus Deploy. And we're going to use that as the excuse to show you some of the nice features of Octopus, some of the nice features of GitHub Actions, and most importantly, how the two tools can work together really nicely to solve these, because we think they can. And so I will start by, let's take a little baseline here. So this is the type of workflow that you might see in a typical Hello World blog post. And we're going to use this as our baseline. So you see we've got a build and a couple of deployment stages to environments. Okay, great. Now, what are the type of problems that we're going to hit as we move past this? So first of all, CI is not CD. This is a drum that we beat relentlessly here at Octopus. CI is not CD. They're a completely different set of concerns. CI is all about ensuring that the code that you commit meets certain requirements, like, it compiles is a good one, it meets coding standards, unit tests pass, etc. CD, continuous delivery or continuous deployment, is all about getting that code into production. So different problems. They have different events that trigger them. They have different folks who interact with them. And the artifacts are different. So in CI, the thing that is typically being kicked around is the git commit. In CD, the thing that is being progressed through those environments is typically a set of built artifacts, what we at Octopus would call the release, and the container images and zip files or whatever it might be. So CI is generally stateless. Like, you can generally rerun CI from the same commit and you're going to get the same result generally. CD, that is not necessarily true for. CD has state. You care a lot about what's happened in the past and what the current state of the environment is. And finally, CI is, in our experience at least, generally much more similar across organizations and across applications within organizations. There are a few variations, but the general gist is usually the same. Like a Go build or a .NET build look pretty similar. CD, this is definitely not the case for. It's very customized to each organization's requirements and each application within that organization's unique set of needs. Okay, so that's probably a good cue, I think, to jump over into our demo application over here. So what we've got set up here is a Git repository that's going to represent our sample application today. It's a simple little Go application. The application itself is not important here. What we're interested in are the release pipelines for it. So let's jump in and have a look at our GitHub Actions. And one of the first things you'll notice here, I hope, is that we've split out our CI and our release pipelines. So we've got our CI workflow here, and we've actually got two release pipeline workflows. We've got release main and release pull request. We're not going to spend really any time on the CI workflow today, but it's a very simple, just runs a Docker-based build. But the one thing I think to notice here is that we've actually got this configured to run on commits that we don't want to release. So we want to make sure that our commits keep our repositories in a known state. But for commits to our main branch or pull requests to our main branch, that's what's going to trigger our release workflows. And that is probably a good cue to jump back to the slides for one moment and to skip to our next typical challenge, and that is branch-based pipelines. So, Git has become the place where development teams store everything. So it's probably no surprise that these Git concepts influence the way that we ship code as well. And what we see is it's very common for release pipelines as well to be driven by Git branches currently. Specifically, what we see are things like events like creating a pull request. You often want to deploy to some sort of development environment so you can have a look at the change and test it out. And it's also pretty common for merges to main to be the indicator that this is a commit that's intended for production. So main branch represents production. Again, there's many different ways to hold this, but this is a fairly common one. So let's jump back over into our demo over here and see how we've modeled this in this world. So let's start with our main release pipeline. You can see that it is triggered on pushes to the main branch, and it uses this build and push image workflow, which we'll dive into. We've created this as a reusable workflow because we use it across both our release pipelines in this case. And it's nothing too out of the usual here. We check out, we capture a little bit of metadata that we want to use for the container image name that we're building. We capture a bit of metadata about the branch, again, for the same reason, so that we can stamp it on our container images. We run a Docker build, and we tag our image. We push that build to the GitHub container registry. We've got this over here, which we will come back to later. And that's our build and push pipeline. So let's jump back over to our release main pipeline. So once that build and push has happened, we then log into Octopus and we create the release in Octopus. And this is where we hand off the release to let Octopus do its thing. One nice little new feature here that's worth calling out is you'll notice there are no credentials in this login to Octopus action. So we're actually using OpenID Connect to integrate with Octopus, which is really nice. It means we've configured the trust for this application over on the Octopus side, and we don't need any Octopus credentials here on GitHub. So that's something that's rolling out right at the moment, actually. And that release is created, and that's probably a good point to jump back to our slides and talk about our next challenge over here. So our next challenge we're going to look at is dynamic environments. So historically, the canonical lifecycle for an application was something like dev, test, staging, production, this series of static environments that releases would progress through. But the combination of the rise of cloud providers and combined with infrastructure as code tools like Terraform and Pulumi, these mean that it's become increasingly common over the years to want to use dynamic environments. So especially for things like previewing pull requests, there are a lot of advantages to using a dynamic environment rather than a static environment. And just to think about a few of those, well, number one is if you've got a static or one or two static development environments, it means you're sharing them between all the folks building features for that pipeline. So if you've got 3 features you wanted to test at the same time, now you need to share them across 2 or one static environment. And the advantage from the other side is those static environments, they're generally provisioned whether you're using them or not, whereas dynamic environments, you can spin them up, test your pull request, and tear them down again. So let's jump back over to our demo and have a look at how we handle that over here. So let's jump across. So that was our release main workflow. Let's use our release pull request workflow now. So the trigger for this one are pull requests being created on the main branch. And you'll see it starts off like our main release pipeline. It does a build and pushes the container image, and it logs into Octopus. And now is where we do something a little bit different. So what we actually do here is we've used a different one of our Octopus GitHub actions. Before we've created the release, we're invoking this runbook called provision branch environment. We're going to wait for it to finish, and then we're going to create the release. And let's use that as the chance to jump over into our Octopus project. So we've been up till now looking at the GitHub Actions side of things. Now we're over on the Octopus side. And you can see right away on the dashboard here, we've got a couple of channels in here. We've got our release channel, and this is where our main changes that are applied to the main branch come down. So this more resembles our typical static environment lifecycle. In this case, we've got main, staging, production. So the main one here represents whatever is committed to main at any given time, and we'll have a look at these environments later. But of interest to us right now are these channels. So what these actually are dynamic environments that we've created just for pull requests to deploy to. So let's jump into our runbooks over here, and you'll see we've got a create branch environment and a destroy branch environment runbook. And this create branch environment runbook, what it actually does is it runs some Terraform to provision a bunch of resources in Octopus for the environment. So this is just a little script. It's not doing anything particularly exciting other than doing a Terraform init and running some Terraform. It actually, the interesting thing is we create a new Terraform workspace for each branch. This is what lets us reuse the same Terraform across all our dynamic environments. And let's jump over and have a look at that Terraform, shall we? By the way, I'll make this repo available at the end of the presentation for anyone who wants to have a look afterwards. So if we dive into the Terraform that we're using here, we provision quite a few Octopus resources here. We're actually spinning up a new environment. We're spinning up a brand new life cycle that contains only that environment. We're spinning up a brand new channel that links to our new life cycle, and we're creating the Kubernetes cluster deployment target to represent this environment. And if we jump back over, you can see the result of this over here. So in this case here, this is a feature, an example of a feature that we might have an open pull request at the moment. We've called it quick ship. If we jump to our library and look at the life cycles, you can see we've got our release lifecycle here, the one I mentioned, main, staging, production, and we've also got these temporary life cycles for these features. They have only the one environment in them. And if we jump back to let's jump to the infrastructure and have a look at the deployment targets. So we've got our Kubernetes cluster targets here, and you can see we've got some static targets for dev, staging, production, but we've also got these dynamic targets that we've spun up with our Terraform for these features, and they live just in the temporary environments that we've got. So the end result of this is that we get this nice dashboard that shows us the dynamic environments that are available at any given moment as well. With that, let's jump back to our slides for a moment and look at our next challenge. So we've talked about dynamic environments, but production environments are different. So while we might use these dynamic transient environments that we spin up and spin down, which are great, they're great for development environments, but this is rarely true for production. So production is almost always a pet. It's not cattle. It has a long-lived database associated with it. It has specific access rules. It has monitoring hooked up to it, et cetera, et cetera. In fact, what we often see, as we've just looked at, is that there's usually a handful of these static environments, more than just production. It's very common to have a production-like staging environment to test in with similar hardware, et cetera, before you get to production. Sometimes you might have a disaster recovery environment as well. But yeah, the key thing is here that it's really common to have these static environments alongside the dynamic environments that are treated slightly differently. So if we jump back to our demo application, let's have a look at some of the specific things of this. So another thing that makes production a little different to other environments is that the infrastructure in it can be quite different as well. So if we look at our Kubernetes targets over here, we've actually got, in this case, two Kubernetes clusters in the production environment. So in this case, we're simulating like a multi-region scenario where you want to deploy to US and Europe or whatever it might be. And so the nice thing in general that Octopus lets you do is completely abstract your deployment process away from having to know anything about this infrastructure. And how do we do that? So let's jump back into this. So our deployment process here isn't doing much. It's just running a customized step to deploy the Kubernetes manifests. And if we look in here though, any of you who are familiar with Octopus will be familiar with this concept that steps in Octopus get given these roles. So we want to run against the SHIPPED23 Kubernetes infrastructure. And so when a deployment happens, it goes to the environment that it's being deployed to and uses that role to fetch the right set of deployment targets to deploy to. And that might be a dynamic cluster we've just spun up, or it might be multiple static production clusters that we've configured. And this is nice because it avoids us from having to know anything about this. So I think the key takeaway here is that different environments are a little different. And we'll talk a little bit more about that in a second. But first, let's jump back to our slides and jump to the next one, which is release management. So this is another real challenge when you start building real-world release pipelines. And I think this idea of release management is one of the most under-addressed topics in software development in general. So the way that you move your code and artifacts from developers' keyboards through to running in production has a huge impact on, not to overstate it, but your entire organization. So, you know, it really affects the velocity and the quality with which you can deliver software, which makes it interesting enough on its own. What makes it even more interesting is it's definitely not a one-size-fits-all problem. So for any rule that you can think of in regards to release management, any best practices, chances are we've spoken to someone with a very good reason to break or bend them. You know, you see this come up periodically with the should you deploy on Friday or not deploy on Friday debates that typically fly around Twitter every now and then. And the reality is that every organization has their own perspective on this. They have their own goals, they have different constraints, they have different appetites for velocity versus risk, and there's good reasons for all of this. We could do a whole topic on release management, and we probably should one day. But for now, let's jump back over to our demo application over here and see how we handle some of this in our little application. So let's jump back to our main release pipeline. So whenever a commit gets merged to main, we build it, obviously, and then we create a release for it, for every commit. And you'll see that when we create this release, we send it down the release channel in here. And the release numbers, the versions that we're using for these releases, actually, we can jump over to our package repository and we can have a look. So you can see some of the container images that we've pushed to our GitHub container registry here. They use the branch name and the GitHub run ID as the package ID in this case. It works for our purposes. Your mileage may vary on this. So we create the release in the release channel. And what happens there? Let's jump back to our project. And if we have a look at the life cycle for this project, for this channel, we can see here, this is our release life cycle: main, staging, production. As I mentioned, main we basically treat as a tracking branch for main. So every commit that gets pushed gets immediately and automatically deployed to our main environment. So you've always got an environment that represents your main branch at any given time, which is nice. For staging and production, what we do in this case is we've set up release triggers to say we want to promote that main branch to staging each day at 9 o'clock in the morning. So that's our cadence that we use to effectively batch a release. We think of it often as a release train. That's when the release train leaves. And every day we also take what's in staging and promote it to production at 8 a.m. So we do it just before, so that if we need to roll back, we can always have a look at what's in staging. So that's the release train, the way that we've modeled it for this application here. And again, there's no right way to do this. It depends very much on your own requirements, your application's requirements, but that's what we've done here. And we're also not restricted to those time triggers. So let's imagine we found a bad bug in production and we wanted to push it through. There's absolutely nothing stopping us from coming in here, committing our change. It'll be deployed immediately to the main branch, and we can bang on these deploy buttons here and push it all the way through to production as fast as we're comfortable to do with. So we've got a few different ways to handle things. If we jump back over and have a look at our release pull request workflow, again, we create the release in Octopus every time a commit is made to a branch which has a pull request open on it to merge it to main, for a pull request against main, I'm sorry. And but you'll notice this time the channel is dynamic. So the channel isn't fixed. The channel it uses is the one that matches the branch that's been deployed to. And this won't surprise you, but these match with the single environment that's automatically deployed. So every change to a pull request gets automatically deployed to its own custom environment, and that's it. That release does not progress to any other environments. We want that change to go somewhere else. We merge it to main. Again, that idea of a branch-based workflow is how we trigger that. So that is how we've modeled our release management in this project. Let's jump back to our slides for a moment and talk for a minute about roles and responsibilities. So this is the next challenge we want to talk about for modeling real release pipelines. Not everyone in the world is a developer, and I know I was shocked when I first realized this as well, but it is true. And again, back to our first point, this is one of the ways in which release pipelines really differ from build pipelines. It's very common for a build pipeline for no one to care about it other than the development team that's working on that project. Generally, this is not the case for release pipelines. For release pipelines, you really do want to segment your rules and responsibilities. So what am I talking about there? It's very common, especially in large organizations, for development teams to be responsible for deployments to the lower environments, the one that they own. So for example, our transient pull request environments in this case, possibly that main branch environment. And then for the production environments, for them to be owned effectively by a different team, some sort of centralized operations or platform team. And you sort of want some walls in between those two. And this is really where Octopus shines. It's got a nice set of features to enable this. So if we jump back over to our demo application for a second, the sort of things that you can do in Octopus here. So let's actually just have a look at our teams here. So what we can do is, you might have members of a development team that have the ability to manage environments and deployment targets for the development environment, but not for the production or staging environments. And on the flip side, they have full project contribution rights for the project itself. And then on the other hand, you may have you may have your ops teams configured where they have various infrastructure management capabilities across all environments, so they can absolutely go into production and manage the infrastructure there. On the flip side, they're not too interested in changing things within the project. They don't mind so much. So what this lets you do is set up those kind of clear boundaries between the two groups. And excuse me, I'm sorry. And again, as we mentioned earlier, the way that the deployment process lets you use those roles really lets you abstract those away. So the time you're writing the deployment process, you don't need to know which environment it's going to be deployed to. You can even segment it further than that so that you can't even see certain groups can't even see these other environments. You've got a lot of power at your disposal to be able to really configure those boundaries between the teams. And yeah, let's jump back to the slides. And we will jump to our next point, which is that it's never perfect. So, CD pipelines are complicated. They integrate many tools, cloud providers, Kubernetes, tools like Octopus and GitHub Actions, Terraform. These are complex tools solving complex problems. The reality is you are going to hit snags as you model these scenarios. I'm too embarrassed to show you how many runs it took me in Octopus and GitHub Actions to configure this example, but it was many putting this demo together. And I think it's important to remember that perfect isn't the goal for creating these type of pipelines. Better is always the goal. We often find that the folks we talk to are maybe almost embarrassed about the state of their pipelines because they assume that everyone else's are perfect and very advanced. And definitely here to tell you this is not the case. All the organizations that we work with exist to deliver value to their customers, not to have the world's most perfect deployment pipelines. So I think the key takeaway here is being pragmatic and solving the problem that you have in front of you, and not being realistic that it's not always going to be exactly the way that you want it to. And that was a interesting little rant, but I want to give you an actual example of the way that this played out in this project. So if we jump back over to the demo, I was up late one night as I was putting this together, and I was really struggling because in this dynamic provisioning, was trying to get it so that the authentication was working with the dynamically created Kubernetes clusters. And if you've ever worked with the identity management in Azure AWS, you'll know it's the most complicated part of the whole system. And I was struggling to get it working, and I couldn't get the Terraform to provision it correctly, and it was frustrating me. And so what I wanted to do then, to cheat, as we do, is to come in, and all I wanted to do then was to select login with administrator credentials. I was like, forget about using the Azure AD RBAC. I'll just, these are just dev sandbox Kubernetes clusters. They're not connected to production in any way. The resources in them get torn down regularly, so I'll just provision it like this. Except there was an issue with the Octopus Terraform provider we use where that was struggling, and I thought I might have to make a change to that. And where I landed in the end was that, as a temporary measure, I decided that I was just going to add a manual step to the run book so that for the first time it's run. And the way that we do that is in here. The first time when we actually provision the Terraform workspace, we set an Octopus output variable saying that we've just created the workspace. And then in this next step, we bind it to it, and we run only if that is true. And it sets a manual action so that pauses the run book, and we can come in and check that checkbox here to say use local admin access in this case, and then continue. Not perfect, but you know what? We'll see how much it annoys me, and we'll fix it if it annoys me too much. And I think, as you model these complex real-world pipelines, you're going to hit many issues like this, and being pragmatic is the way to get around them. So let's jump back to our slides for one last time and say that it's time for the working demo. So back to the demo again for a second, please. And I am going to well and truly invoke the demo God's wrath here by looking to do a full end-to-end workflow of how this plays out. So let's do it. What we're going to do is let's create a branch for our new feature. So we've got quick ship, we've got safe ship. I think we need a secure ship branch. Let's do it. Let's go and make a code change that we can push through. See, this is going to make it more secure because we're going to remove some exclamation marks. They were definitely a risk. Let's commit this change and see what happens. So we jump back over to our GitHub Actions here. And we can see that our CI is running. So this is our CI build, making sure that our code compiles, that our unit tests run, all those good things. Because of course we always want to have our code in a known good state inside our repos. But you know what? I think it's time for us to create a pull request for this change. Pretty happy with it. Let's create the pull request. Now let's jump back to our actions and see what happens here. So now you've seen that we've created that pull request and that's triggered our release pipeline. So this is the one that's going down the release pull request workflow. Let's dive into here. Our CI there passed, as we would hope. So this is going to build and push our container image. So let's watch that happen. And what we should see in a minute is that show up in our GitHub container registry over here. And there we go. So as I mentioned earlier, we are labeling our, we're tagging our images with the name of the branch and the run ID. So we've got our secure ship. And if we jump back here, that workflow is now triggered the runbook in Octopus. So let's jump over and have a look at that. So we can see our create branch environment runbook is being executed here. Very nice. That's going to go and run that Terraform that we looked at earlier. So it's going to be creating the environment, the lifecycle, the channel, the deployment target in Octopus. And now we've seen that our manual intervention has kicked in. So this is saying that it's paused and awaiting for us to do something, which I really like this as a pragmatic feature in Octopus. So let's jump over to our infrastructure tab and look at the one that we've just created here. So here it is, our secure ship. So what we can come in here and do is say, let's log in with the admin credentials for that. It's not best practice, but it's a temporary development environment. So let's go and continue. That runbook will now complete. What we should see is the next job that we'll run is we're now creating the release for that in Octopus. So if we jump back over, we should see, here we go. We've created the channel, we've created the release, and it is now getting deployed to our brand new environment that we've just spun up for this. One of the really nice new features recently as well is this Kubernetes object status. So we can actually see in real time the status of the Kubernetes objects as they're being provisioned here, which if you haven't checked this out, I definitely recommend that you do. And we've seen that that's succeeded. So we're not going to worry about actually looking at the application over there. That's not the purpose today, but this is where we would normally go and use it and make sure our change was what we wanted it to be. And let's assume that we have, and we verified our pull request. So what we can do now is jump back over to GitHub and look at our pull request. So this was, let's say we're happy to merge this. So we've now merged that into main. So let's have a look what happens with our actions now. So two actions have triggered here. One is the release. We're now creating a new release, which is going down our main release channel. The other one is one to deprovision the temporary environments that we've just spun up. So let's jump over into Octopus and see how this plays out over here. So we'll notice that for this main release workflow, we still do the build and push. But what we don't need to do is provision any temporary environments. It's going to create a release in the release channel here, which will be automatically deployed to this main environment any second now. And meanwhile, our destroy branch environment runbook should also be running over here. Let's have a look at that. So that's run there, and that will have torn down our secure ship environments. So if we jump over here, you'll notice they've fallen off the dashboard now. They've been cleaned up and all gone. And our release to our main is now rolling out. And once that's done, we will be able to go and view the application as it stands on the main branch. And then automatically the following morning, it will be promoted to staging. And assuming no issues are found in there, it'll be promoted to production following from that. And success. So that is an end-to-end run through. Well, I guess actually it's not quite end-to-end yet, is it? We should come back in and we can even, if we want to, if we're impatient, we don't want to wait for the next morning, we can kick this along and trigger the staging deploy in here as well. But yeah, I hope that's an interesting look at the way that we can model some of the more complicated real world problems you hit when you start modeling release pipelines, and how you can do them you can handle those using a combination of GitHub and Octopus together. And if we jump back to our slides one last time, we will put this up so that we can use that as the resource. You can come along and have a look at that repo on your own time, and it will stay there as a useful reference. And yeah, I hope this has been informative and helped show how powerful Octopus Deploy and GitHub Actions can be together for modeling CI/CD workflows. And with that, thank you for having me.
All right, hello everyone. Today we are going to talk about what lies beyond GitOps and how to apply these GitOps principles to your actual real-life deployment to Kubernetes, especially when you scale to many, many clusters and many, many apps and tenants and environments. So I'm Kit. I'm a senior product manager from Octopus, and this is...
G'day, I'm Rob. I'm one of the principal engineers here at Octopus.
Right, so for the last year or even more now, Rob and I have been working on Kubernetes experience in Octopus, and we've been meeting multiple customers every week and ask them same question, like, what do you like, what do you not like about Kubernetes deployments, and how hard it is for you. And we learned eventually that the problems people face are actually more or less similar, and the thing they're looking for are similar too. So we tried to combine it all in this one talk, and we will start about the best of all the most known and best concept for continuous deployment, which is known as GitOps, what it is, why it's great. Then we talk about the common issues and limitations we see with GitOps, especially when people apply it at scale, and how we can address it with Octopus. And then at the very end, we talk about a hypothetical example and just a few quick tips on how would we configure deployment to Kubernetes in Octopus so we can benefit from all the best practices, but also avoid some pitfalls. All rightish. So let's talk about GitOps. So the thing is, GitOps is a vague term, right? There are no unified definition of what GitOps means. Lucky us, there is actual initiative called Open GitOps, and these people try to get together and just clarify the GitOps meaning. So we will use their terms and definitions, but it's very likely that you find a lot of other interpretation of the same term. So basically, in a nutshell, GitOps is a set of principles for operating and managing software systems. It doesn't tell us much, right? It's too generic. So let's talk about 4 actual pillars which usually define GitOps. So the first thing is GitOps and deployments with GitOps meant to be declarative. This movement started way before GitOps, and it's all about just instead of applying step after step after step to achieve my desired outcome, I want to define the outcome as a file, declare this in some kind of a manifest, and then my platform will do the changes, do the magic. I don't even know what exactly will be done, but eventually the platform will achieve the desired state which I declare. When I think about this, we naturally think about Kubernetes, but it's not the only declarative platform. There are multiple. The second one is deployment should be versioned and immutable. And that's an interesting one, because basically what it says that once you have the desired state, you should be confident that nothing will be changed there behind the scenes. So it will be exactly as you left it. And then when you change it again, instead of changing the state, you'll create a new version of the state. And now you'll have 2 versions, version 1 and version 2, and you can switch between them and always basically go back if the new version didn't actually work. The third one is pulled automatically. And this is a bit of a tricky one because what it actually says is just as soon as I have the new version, my deployment tool or my automation tool should identify that the version is there and get it, instead of me doing extra effort and trying to basically push this configuration to my deployment target. And finally, it's about constant reconciliation. That means that my agent, automation, deployment tool should always check the status of my target. And if, for some reason, the status doesn't meet the desired state, well, it should be fixed. And there are multiple applications of that, which we'll discuss a bit later. Rob, which principle do you like the most of this?
Which principle do I like the most? I think the idea of having it sort of declarative is nice as an engineer, right? Being able to actually look at it. Let's have a bit of a chat now and talk through at a super high level what the GitOps flow actually looks like. In this scenario, we're going to deploy to a Kubernetes cluster. GitOps itself doesn't actually say anything about what targets you should be deploying to, but Kubernetes is the common one since that's part of where this GitOps movement kind of originated from. It's all about being declarative and immutable, just like GitOps. We're also pushing to a Git repo. Now, the first kind of mind-blown point here that I'll bring up is that GitOps, despite its name, actually says nothing about Git itself. It just fits really well into being declarative, versioned, and easy to pull from. I think this is sometimes the cause of some confusion from people. It creates some strong opinions, sometimes some hand-wringing when practitioners worry about what will happen if they stray from the gilded path. Yeah, so anyway, let's talk about this flow. So as an engineer, I designed my Kubernetes manifest. I add some details to it for a new pod. Let's say I push it to Git. I've then got a CD agent, so that could be something like Argo CD or Flux, something that's sitting there watching those changes from the repository, takes a configuration and applies it into the cluster. In the case of Kubernetes, it will then take responsibility for ensuring that all the desired state meets the required state. So it's really nothing more complex than that ultimately. So why is it good, Kit?
Why is it good? And we're entering very opinionated territory, so be prepared. So I believe personally that GitOps is great because it gives you this one source of truth and the history. So basically, yes, I know what's running on my target, on my, let's say, Kubernetes cluster, because I can literally see the file, see the manifest. And it says exactly what's there. Number of ports, a container I want to run. I can examine this in a readable, human readable manner. And also, I can see the difference between the previous version and the current version. Okay, something isn't working. Why? Oh, because the port was changed, or the container tag was changed, or something else. I can inspect that. The second thing is it's one process. We can manage our infrastructure or our deployment target configuration the same way we manage application code. There are some caveats, which we'll talk about later, but in general, having one process, maybe one set of tools, it's very convenient and very neat, and it bridges the gap between different teams, potentially if you have like platform teams or ops team and software teams. It's simple, not always. Sometimes it's very hard to configure, but when you run it, when it's already working, it's simple to change the manifest, create a new version of your process, or just deploy the new app. And finally, which very aligned with like first and second, it's actually what you see is what you get. So you have one manifest with 5 resources, you will have 5 resources, right? So no guessing here, no magic in between, except for the one happening on the cluster side, but that's not in your pipeline. Your pipeline does very simple job, and you see how it works. You can predict the result. The next question is when it just works. And here I mean not when the GitOps principle works. The principle works like arguably everywhere. It's usually when we talk about GitOps, we also mean some very simple common implementation in mind. Something like a process Rob showed us earlier. So when the simplest process works, I have just one tool, I manage everything in Git. This tool pull configuration from Git and push it into my target. Well, there are a lot of scenarios. The first thing is when you're just starting, the early days, you have maybe just a few teams, and you may be doing some POC for the new app or new platform. Then it works great. It's easy, fast to configure. Immediately, it's easy to push the changes. It will immediately appear on the target. So for early days and small project, great idea. The second option is when you have one app or one configuration and want to deploy it without changes, the exact same configuration, exact same app, without environments, but just simultaneously across, let's say, 500 targets. That's a typical cluster bootstrapping. I want to have monitoring app or logging app on my cluster, and for these scenarios, it works perfectly fine. Finally, if you have maybe many teams, but they're independent. One team works on this app, and this app has nothing to do with the other app, which the second team is working on. In this case, the simple process will do the job. And finally, just if you don't have yet that many apps, environments, and tenants, you still can manage the typical process. Yeah, maybe it will be a bit manual, but still good.
A lot of things about this, is just to sort of really highlight that. A lot of the things about this is about scale. It works well in small scenarios right off the bat.
Yeah, that's really true.
Let's talk about them. Let's talk about those limitations you get as you do start to grow. One of the most common problems that people come up against when they start using GitOps is how to deal with sensitive variables. How do you deal with secrets? Almost every project we've got are going to have secrets of some sort, whether it's connection strings, API keys, passwords, that sort of thing. Sometimes infrastructure, sometimes application. GitOps doesn't really say much about this, right? Which is good that it's not opinionated, but that can now be a problem because we now need to solve that. Let's have a look at what some of the options that are out there. In this example, again, I'll talk about it from the context of Kubernetes, since that's probably the most common GitOps scenario find, but a lot of these principles are going to apply more broadly. So secrets are the native Git Kubernetes format. Basically, you base64 encode your secret, and you store that directly in your resource manifest. And when you push that to the cluster, it basically just makes use of it directly. Hopefully, as I explained that, it's fairly clear why that's not a good idea to store in your repository. The secret itself is just base64 encoded. That's like leaving the keys on the roof of your car at the shops. Not a good idea. So sealed secrets is a common pattern to sort of overcome that problem. Basically, what you do is you generate a public and private key. You store the private key in your cluster alongside with a controller, and you take your sensitive variable and you encrypt it with your public key. That encrypted value now you can, in theory, store in your repository, and when that gets into the cluster, the controller will take that private key, decrypt it, and it's sort of safe to use inside. Note that while it's encrypted though, that password though is still out in the open. And you might say that keep in mind that the recommended key size and algorithm has sort of changed over the years. At some point, something that we've considered secure could be easily brute forced. So why take risk with something that, based on Git being one of its key strengths, is you keep those values around forever. You're potentially leaving those values for later decoding. Imagine if you told your clients that their password to the database was out there available to everyone, but don't worry because it's all encrypted. They'd probably ask why make it available in the first place, right? On top of that sort of hypothetical problem, you've got the more material problem of how do you deal with key rotation. So, it's encrypted, but at some point you're going to need to rotate that public and private key. How do you deal with that? Unless you're rotating every single underlying password and cert, you've probably already got them stored somewhere else. That's potentially a big task, particularly as things start to scale. So one of the solutions to this that is becoming more widespread is the idea of external secret operators. So this is obviously a gross simplification, and there's some variance between providers, but the general principle is that you're storing some non-sensitive properties in your manifests that when they get into the cluster, the specific secret operator will pick up those values from your manifests, and using the internal keys, access your third-party key store and bring them into the cluster. And as I explained that, you kind of hopefully realize something, that now what we're talking about is storing some of these properties outside of your repository. The secrets themselves are not stored in the repository. Is it the case that we're not in GitOps land anymore? Actually, that's good. That's fine. This is still aligns with GitOps. Mind blown idea number 2. GitOps doesn't say anything about where that source of truth is, or that there is even a single source of truth. We often hear adherents talk about everything needing to be in Git as a single source of truth, but that's not really explain why that's a name. Indeed, GitOps itself, if you look at those practices, they don't make any mention of this idea of it must all be in a single source. So that's completely fine. Octopus solves the problem with secrets in a similar way to external secret operators. It simplifies things even further though. All you need to do is provide in your relevant manifest an octostash templating variable. And since in this case, Octopus is your CD tool, it has the environment context available and it ambiently applies it as part of the deployment. So it knows what value to pass in during the deployment. This is injected directly in and stored in the cluster without running any additional custom controllers inside your Kubernetes cluster. Really nice. Because ultimately, if I start with one manifest and I just push that to dev, that's all good and well. But at some point, I'm going to want to make some slight tweaks, say to my production environment, because I want more replicas or something, and I want to make sure that those changes sort of persist through the environments where they make sense. So how do we deal with that? A common mechanism that a lot of people started with was this idea of branch per environment, and that kind of feels fairly natural initially, right? Particularly as an engineer, it feels like like with Git flow. I make my changes to a feature branch, and that's the thing I'm testing until I'm happy and fine for it to go to production. I merge to the main branch, and that's the thing that designates what goes out to production. The reality is, though, there's a big difference between what you're doing with your application code, where you're effectively resulting in bundling at once and moving around between environments, and in CD, where this environmental concept is exactly the place where that relationship matters. So it needs to be properly modeled. It actually creates a high risk of drift. In this scenario here, there's nothing stopping me from making changes in, let's say, staging after I've merged from QA, because at the end of the day, they're all just fundamentally Git branches. There's a high risk of breaking things that have been validated in earlier branches. Again, there's nothing stopping you from changing in production. And that creates potentially merge conflicts, because now I've made a change in production, which I need for the production environment. But when I merge that change from staging, I need to understand and only overwrite those values that actually have changed, as opposed to those that need to stay there for the environmental differences. It's also very high touch. So this makes it difficult for any sort of automation. And you've got security issues. So it's difficult to control who has access to the different environments across various different branches, and it completely depends on what tools your Git provider provides you. Repo per environment, that partially solves some of our permission problems. We can have controls on who can access what environment, but you've still got that risk of drift. You've got this complete disconnect between environments. Again, there's nothing stopping me from making changes in one that haven't gone through the other. And progression is a little bit unclear now. It's not really obvious to me or really enforced what environment needs to go out before the other. At the end of the day, it also doesn't really scale well. Again, as you increase the number of environments you've got, and you potentially multiple tenants, and that's per project, this can really get out of hand. Folder per environment is one that is a lot more common nowadays, and it's modeled by having a separate folder, typically within a single repository, where your CD system will watch for a single default branch like main and master, and that's where it reads from the different environments. The nice thing about this approach is you get the benefits of templating with shared resources. On the flip side, with shared resources, you've now got a new and novel opportunity to break things, where if I'm using some shared resource that staging and production are using, I need to understand that by making that change, I might be impacting production. Also, you need to start asking that question about what am I actually promoting? If I've successfully deployed staging, but that was 10 commits ago, when I come to then merge that into production, the commit that I need to merge is actually what staging was 10 commits ago, not the current one. The development pattern is also a little bit messy. If I'm a developer making a change in my feature branch and it requires some changes to my testing environment, I now need to either wait for that to merge into master so I can test it, or I need to make some changes in my master branch, because that's where my CD information is, that correlates with my application changes in my feature branch. This is partly why a lot of users will start to actually separate their CD manifests and application code into separate repos. It embraces that reality that the single repo shouldn't be the single source of truth. Again, scalability problems. As we add more and more environments, we've got more and more merge conflicts and things we need to deal with. Actually, Kit, you talk to a lot of customers. I'd be interested to hear what are some of the patterns you're seeing customers do in this space?
Well, I think the first one and the third one are the most popular. And as you said, exactly. So as soon as you have just few environments, I think people opt in the first one. And then as they grow, I see a lot of scripts, and then script triggering script, and another script triggering these three scripts in sequence, trying to orchestrate that. And it can result in very complex permission control, like which script or which person can do what with each branch. So, and yeah, that can be, it works in the beginning, could be messy in the end, at the end. And then if you have a lot of, especially if you have tenants, like you have one cluster, for example, per customer, or you have North America, Oceania, Asia, and Europe region, in this case, you will opt into folders. But then again, you'll probably struggle with the same problem you described eventually. So I would say these are popular, great in the beginning, hard and get harder and harder as you grow.
Yeah, that's interesting. Yeah, and that follow from environments definitely seems like it's a popular one now, and it does make sense because this is something that like Customize and those other tools have really started embracing. There is a fourth way though, right? The Octopus approach to environments and environmental progression. It takes this idea and makes environments and environmental progression a first-class concept. Since at its core, Octopus is a CD tool, and in a CD tool, these concepts are critical to the whole process. We've got as a way of managing that, we've got very granular permissions. So solving some of those permissions problems, flexible RBAC controls. You can define on what environments and who can deploy. Again, it's made in the product as a first-class concept. Templating, as you start templating different environments and defining them that way, where you provide the variables that are needed for each environment, you get limitless scalability. You don't have to deal with that problem of drift or merge conflicts. Environments and life cycles. Again, by modeling these as first-class concepts, you can sort of control them in a clearly defined and predictable way. You don't need to guess as to understand, have I merged to the right environment because it's been validated there. And on top of that, you can actually automate it, right? With a lot of those Git-based approaches, the high touch that's involved with any sort of pull request means it's pretty unlikely you're going to be able to do that in a really automated way, which is kind of at the core of any sort of DevOps process, really. Releases and snapshots, and we'll talk about this a little bit further later, allows you to build once and deploy many times with none of those sort of poison merges that you kind of risk otherwise. Excellent. So we've talked about some of the potential problems in that space and how Octopus helps solve that. Now let's have a bit of a chat about some of the ways that people are, some misconceptions, I suppose, of GitOps and how leveraging Octopus will solve some of those missing pieces. Not only does it make sense, but aligns with some of those GitOps core tenets. So we'll start by talking very briefly about drift detection. Disclaimer, I know as I say that, it's not that I think in and of itself drift detection is a bad idea. What it does, though, is it just raises its own questions that are sometimes, I think, left unanswered. Now, continuous reconciliation, one of those core points that Kit described earlier that's part of GitOps, can be summed up as sort of being two phases. The first, and I think the stage we kind of think of initially, is that idea of, I make a change in my repository, I've got a process which is sitting there watching that repository, and it gets pulled into my target. The second, though, to the right of that process, involves ensuring that desired state continues to hold true if any ad hoc changes are made to the target. So in principle, that part of drift detection sounds great, right? But I think it misses one of the questions that should be asked when drift is actually detected. So why was drift taking place at all? This potentially hides the question that instead we should be asking about the permissions and access to your system. Why are those unknown changes even happening to your system? A colleague of mine, Matt Casperson, made a really good analogy in one of his blog posts about this. Imagine you've got some guards at your factory, and one night they evict some trespassers, and you think that's great, they've done their job. My security still stands in my factory, all good. If that starts happening constantly, though, say multiple times a week, you're probably going to want to start wondering why you're having this problem at all, and if the occurrence of this is becoming a sign of some broader access problems in your facility. Drift detection isn't a bad thing, but one of the ways that sometimes lean on this too far is to use it as a tool to protect themselves when engineers need to get in and make changes to code. Engineers or ops personnel will sometimes be given access to the cluster to perform, say, maintenance tasks or update various components. Drift detection ensures that any accidental changes that apply to their application infrastructure can be rectified quickly. On top of this, sometimes the ability to turn off and on drift detection, or reconciliation in general, are made as first-class controls in some tools. And this allows for slightly more permanent changes. But this actually undermines all the controls and auditing that are some of the very core ideas and principles that GitOps are there to help us solve. With this in mind, at Octopus at the moment, we don't really put a huge emphasis on drift detection. Our focus is primarily on prevention. And that's why that rich security and permission model I described earlier is first and foremost ingrained into what we do. On top of that, Octopus actually allows maintenance tasks to take place through runbooks. And these are like the ops equivalent of deployment processes. These runbooks still operate within the boundaries and fine-grained security controls that allow you to define who can access your production infrastructure, but it really puts the emphasis on prevention rather than reaction. Another interesting topic to talk about is that distinction between CI and CD. So, think about how often do you think changes from your code and your application are flowing into your CI system? It scales pretty linearly with the size of your team, right? It could be tens or hundreds or maybe thousands over the course of a day. And we probably want a good number of them to flow through to a deployment, even if you're practicing continuous delivery and the changes end up sitting and waiting in the test environment. What about changes to your infrastructure manifest? Kit, how often do you think you'd be making changes to your infrastructure manifest?
Depends. So you can scale up, scale down, but generally speaking, I wouldn't expect more than once a week, every couple of days the most.
Yeah, exactly. I imagine maybe a couple of times a week if you're particularly active. In many cases, once you've got it stable, you're probably not going to touch it for months, right? So unsurprisingly, it's common for teams to rev their application changes at a different cadence and a different manner to their manifest changes. When you're using that single shared repository for this, though, and you're trying to chase that single source of truth idea, this can be tricky for you to hold in your app. Your CI tool generates a new artifact, and then something, either manual or automatic, needs to go back to that same repo and update the number baked into your manifest. When you're doing that, obviously make sure that your CD system doesn't trigger off another build because of that change. Otherwise, you're going to get caught in a loop, and that's going to get quite expensive. We see evidence for this realization in a lot of tools that we typically consider to be Kubernetes native, allowing the revving of images as an independent process from the manifest themselves. For example, Argo CD, image updater, allows you to change the image on your clusters independently of the manifest state. So when you start with a single environment, perhaps with a single engineer, it kind of works fine. Your artifact gets built, it triggers a new version update of your manifest, and ideally automatically triggers that reconciliation process to apply it to the cluster. all good. As soon as you have multiple environments, though, you now need to manually perform some sort of merge process between environments, opening up to all those risks we described before that can create potential bad updates. This manual and heavy touch part of this process means that as you grow, may start stretching some of that principle of least privilege. That effectively starts giving you access to configuration files in production. Everything like pull requests here introduces that risk, particularly once you start adding, scaling also your organization structure. Now you need more people to have access to more of those environments. Octopus solves this problem though with the first class concept of release. Bit of a side note, for a while there, I'll be honest, I was often wondering why customers were using Helm for internal applications. In my mind, it made a lot of sense for sort of distribution of a mechanism for libraries. I've since come to the realization, though, that Helm packages for internal projects are trying to solve this same or similar problem that an Octopus release does. It takes all the details for your deployment, your variables, your process, your templates, and snapshots them into an authoritative source of truth. And this is passed around in your CD system. And notice I didn't say single source of truth, it's just the authority. An Octopus release, however, takes that one step forward and not only defines what gets deployed, but through the capabilities of environments and lifecycles defines the where and the when. This concept guarantees the safety of that desired state moving forward, avoiding most of the risks we saw in those earlier cases. This feature allows you to practice GitOps actually in closer alignment to the core concepts of DevOps as well. The release definition is what allows you to really trust those automations and empowers your teams and policies that build them. The idea here is really focus on the right tools to build, test, and publish your code, and the right tools for deployment. So keep in mind that, with the spirit of the 12-factor app, we're all used to building applications once and using the same artifact across all our environments. That's a realization that I think the industry has come through for a long time. Now, really, we should be taking that property, though, and extending it to your CD artifacts, your manifests. There's no reason your declarative manifest should have to keep updating with every single build and every single commit that comes off your CD pipeline. That's really not necessary. So, with all this background in mind, Kit, can you have a bit of a talk to us about how you'd actually apply some of these practices at scale?
Yeah, so let's talk about how to configure Octopus to deploy to Kubernetes, and more about what we think you should keep in mind to make it simple, manageable, and also benefit from all the best practices we talked about before. So before we begin, let's imagine where these problems, like scale problems, would really hit you. Does mean that all the recommendations won't apply for any other scenarios. They do. It's just here you'll probably really feel the pain, and then the recommendations will really help you. So imagine you have 20 teams and they work on hundreds of services. So each team deploy a dozen of small applications, and these applications are expected to run on the same target, and even more, they expect to interact with each other. So imagine that you have multiple regions. Let's say you keep one cluster per region to decrease the network latency, for example. Then imagine that you have a sophisticated process, you have maybe a separate QA team, and you should promote your app and configuration through multiple environments, and then not everyone can just push it forward, but let's say QA engineer can push it to staging, and software engineer can push it on to QA. And then imagine that you have a separate team, because, well, obviously your configuration is now quite big. You have a separate team who manages your CI/CD stack and also Kubernetes. Finally, you might think about using some other services like cloud-native databases or something else to complement your Kubernetes. So not everything could be stored in Kubernetes. And then imagine you have some legacy. Maybe you still have some VMs running somewhere or bare metal machines. And maybe the other way, you have actually some modern apps which run only serverless. Okay, so does GitOps make sense for this scenario? What do you reckon, Rob?
Yes, very much. It still applies, right? This is exactly. I think if anything, this is exactly when GitOps kind of makes sense, right? It solves some of those problems.
Yeah, and I think the main thing here is all the benefits, like you can have a version, you can have immutable declared configuration. All the benefits are even more important here because it's complicated. And when you have complicated scenario, then you want more visibility and control.
That's right. I mean, those simple scenarios where we're sort of saying GitOps, naive GitOps kind of just works. To some extent, those problems don't exist because they're simple, right? Like some of that observability problem or that reproducibility problem. You've only got one environment, one person. To some extent, the argument could be that they don't matter as much. It's really those GitOps principles become really important as you scale. So solving them in the way that makes sense, that's kind of what's critical, I think.
That's fair enough. So, what do we recommend? First and foremost, make your project simple. Use one project per one app, per one service, and just don't try to pack a lot of steps into this project. We recommend having one main step, the actual deployment step, and you can add other steps like approvals, select notifications, other validation checks, but try to make it simple. If it's simple, it's easy to create another one, it's easy to manage, you know what's happening, you don't have to dig through like different steps interacting with each other. It's scalable this way. Second, think about steps which we already have in Octopus. Yes, Octopus is a powerful tool, you can run a lot of scripts yourself, but we have a few basic things for multiple scenarios like plain YAML, customize, and Helm. And in most cases, they will just work. And you also have other special features built in. So think about using them. Again, that will make your life way easier. And finally, in some cases, you will have to manage dependencies. For example, you have to update this app only with this app, or update them in a certain sequence, etc. For this case, again, don't use one project with multiple steps. Think about having a master project and just triggering your other project from this project, like a master or orchestration project. Will probably do a better job. Moving forward, when you think about real scale, we think about what if I'm adding my 501st microservice? How can I make it easy? And here we suggest just think about templates. So first and foremost, it makes sense to template your Kubernetes configuration. There are multiple ways of doing this. You can use Helm, you can use plain YAML, but we suggest thinking about Customize. So Customize being a powerful tool allowing you to have overlays per environment or tenant, we can expand it even further and think about having one Customize for multiple apps. So what if you have an overlay per app type? Let's say this is an overlay for API, and this is overlay for database, and this overlay for something else. And then combining this with Octopus variables can allow you to modify it even further for a particular app needs. That's really powerful. So you don't have to replicate the same configuration again and again, and you can change the template on overlay once, and it will have impact on all your apps. Make your life a bit easier. Then, let's say you configure the customize step, create a step template, hide all the complexity, use Octopus variables like system variables to automate as many things as you can, and surface just a few app-specific properties which your software developers have to fill in when they use this template. That makes the job easy and prevent you from many potential mistakes. Finally, use configuration as code. It's great to have declarative Kubernetes configurations. It's even better to have also declarative project configuration. So you can have this source of truth and versions and immutable configuration. And finally, at the very end, if you think about scale, how you scale, think about using Terraform and maybe fully automate creating the new projects in Octopus. Finally, when you think about environment progressions, as I mentioned before, think about using variables and defining app-specific, environment-specific parameters and secrets as your variables. It's easy to manage. With configure as code, it will be versioned, and you will have this one for variable source of truth on one screen, and you can see what exactly happening for each environment, what was deployed, and what's even better, variables can actually be scoped and became immutable as soon as you create a release. So you know which version of this variable was deployed with each release. And sometimes you want to have specific paths for different versions of the app. Let's say one version might be just for developers to test something and it should never end up in production. You want to prevent that. and other versions should go straight through production and all the tenants for the scenario use life cycles. So it will just eliminate some errors which people can make accidentally. Right, and in the very end, going back to the do detection, just try to not provide direct access to your clusters. There is really no need. So we have what we call object status for Kubernetes in Octopus, and you can see your deployment success. So you can verify what all the resources you expected were created and find some basic information about them. You can use runbooks, as Rob showed, for maintenance and debugging tasks. Again, no need to access the cluster, and because runbook steps can also be templated, you know exactly what happens, and you can provide to your software teams all the tools from centralized place. And finally, think about adding some ongoing monitoring and log collection tools to Octopus. So after deployment, you still know what's going on with the app without accessing the cluster directly. And that's about it. We have a lot of samples. You can follow the link and find examples of how you can configure Octopus with different cloud providers, with different tools like Helm, Customize, and plain YAML, how you can use variables, how you can orchestrate microservices. So it's all there, and just feel free to reuse it. Hope it's helpful. Finally, we do hope that you have something you disagree with from this presentation. And
I'm sure there'll be some things that people disagree with.
yeah, absolutely. Maybe like at every second slide. So, and that's awesome. So please, please, please share your experience with us. We want to learn from your experience. It will help us greatly to develop a better product. So please, if you don't mind, just having like quick half-an-hour chat with our
Let's
team
have that discussion.
to share
Have that
your experience.
discussion. Yeah.
Yeah, let's talk about it. So please don't hesitate, and we'd really, really appreciate meeting you and talking about Kubernetes and GitOps.
Alrighty, welcome everybody. Thanks for hanging out for this session. I'm going to be talking today about tracking and performance at Octopus Deploy. My name is Paul Grady. I'm a software engineer, and yeah, thanks for coming here and hanging out for this event. This is pretty exciting, I think, for everybody. So it's the first time we've done this. I'm sure you've heard this a million times. Cool. All right. So the first thing we're going to do is just kind of go through the itinerary for what I'm going to talk about. We'll do some introductions. I'll give you a bit of background on myself as well as the team. Then we'll go through and kind of get into a little bit what we mean by performance. This is probably, you can interpret performance a few different ways. So we're going to focus in on the specific things that we're concerned with respect to this talk. Then we'll talk about, why do we care about tracking performance? What does this do for us internally as an organization? We've got a bit of a history behind this already. I've been at the company for a few years, and I've seen this kind of unfold over the last few years. So we'll go over a brief history of performance tracking at the company, talk about some of the things that we've done to try to achieve this in the past. Then we'll get into the nitty gritty of like what we're actually doing right now, which is the current performance tracking system. So we'll talk about that. I'll share some details around that. And then from there, we'll talk about some of the challenges, of course, with assessing performance in the way that we're trying to do this. And then we'll get into something that I think a lot of people hopefully will find pretty interesting, which is assessing scalability using machine learning. So that should hopefully be pretty cool towards the end of the talk. Okay, so first up, let's do some introductions. All right, so my name's Paul Grady. Again, I'm a software engineer at the company. I have in a former life, I was a data scientist, and so I bring to bear some of my background in statistics to try to help solve some of our, some of the problems that we're finding in this space. But in support of this as well, we've got a whole bunch of people. We've got Ian Core, Matt Shepard, Nelson Suzanto, Bonnie Sang, Felix I, Sean Heavey, Dennis Kostenchuk, Matt Hilton, Rob Wagner. I'm giving shout outs to everybody here because they're all really important people and players in this space for us, helping us deliver a lot of value in terms of performance improvements, as well as a tracking system that we'll talk about. So first question, like what exactly do we mean by performance when we say performance? Like what exactly am I talking about? As you can imagine, there's a lot of ways to interpret this. In particular for this talk, I'm going to focus in on the idea of speed and scalability. So with speed, what I'm talking about is how quickly do requests return from the server, right? That's the main question. And the concern here is, mainly around preventing slowdowns from code changes. And immediately it probably becomes apparent as you think about this that there's a lot of different ways that you could measure this. And I've got a diagram here on the right to remind me about the different layers that you can kind of assess speed with, or speed at rather. So for example, you might be interested in how quickly does the UI respond when you click a button, when you create a deployment, that sort of thing. The UI, the request, or the user interaction with the UI will send a request to the API. The API will do its business and then return. And then you may be orchestrating things at the UI level. You can also look directly at the API surface. So you've got, for example, a client. You may be interacting with the API. You submit a request to update a thing. How long does it take to do that thing? And then just gauge kind of how long that takes. So you've got this idea of like, it becomes kind of complex, this idea of like, how fast do things go? And you've got multiple layers you can assess that. And so we're going to have to decide kind of where the value is for us to make that assessment about whether or not our code changes are causing our product to slow down. The other thing that we'll talk about is this idea of scalability, which is sort of asking the question, how well does Octopus Server operate when there's more data or more server activity? So as things get bigger, as you've got more tenants, as you've got more background processes, we've got a lot of stuff happening beneath the surface in an Octopus server. Everyone's familiar probably with this idea of a task, the task queue. You kick off a deployment, it returns immediately, for example, but you may have 1,000 deployments that are just kind of sitting there being processed in the background. And so you get this idea where you've got what exactly am I interested in with respect to speed and scalability? Is there a lot of stuff happening? Is there a lot of pre-existing state on the server? Are we waiting for the response from the server for something like an update, or we've kicked off a task? How fast does that return? Do we have a lot of, or are we interested in waiting for that task to complete? How do we actually assess this problem? But this is the space that we're operating in with respect to the tracking system and the concepts we'll cover over in this talk. So this kind of begs the question, I suppose. Hopefully this is somewhat self-evident, but in case it's not, why do we even care about tracking performance? I think it goes without saying that we're always thinking about how to make our product faster. And, I think everybody cares when they're making code changes. Is this going to make things go slower? So why do we care about tracking this? We're always trying to make things faster. Well, the reality is that, unfortunately, we ship regressions. Developers, engineers, we ship bugs. We ship changes that we're not always 100% sure what's going to be the impact of that change. And the reality at Octopus is that Octopus Server is constantly evolving. So I've got a list of things that we've done in the last few years that kind of illustrate some of the really fundamental changes that we've made. I think it's pretty obvious that we're always adding new features, we're making changes and tweaking features, but we're also doing a lot of stuff beneath the surface that fundamentally change how the product operates. So for example, we've recently finished a migration of web frameworks from NancyFX to ASP.NET. That was a huge, fundamental change in the way that the server is even built. We've introduced Git as a new persistence mechanism. So we've changed the entire persistence strategy, like how we save and access data in the database to support certain features, for example, like config as code. And in fact, when we first did this, we shipped a pretty bad regression and we didn't have visibility on that. We've changed large portions of the code base to be asynchronous. So I say large portions, not the entire thing. And so when you have the mixture of synchronous and asynchronous code, you can lead to interesting scenarios where there's contention for things like connections to the database and that sort of thing. And in the process of doing this, we have unfortunately shipped some regressions, things that led to deadlocks, or things that were almost deadlocks, where things become very slow as these resources are freed up, basically. We've been recently evolving our caching mechanisms. That's another good example of one of these broad impact changes. This is an interesting one because we actually measured the impact of this change. We determined that there was a slight regression, but we decided to ship it anyways because we felt that the value trade-off was there. And then currently what we're doing is we're migrating from a custom ORM, Nevermore, the thing that we use to actually interact with the database, to use Entity Framework. And so the big picture here is that all of these changes are vulnerable to performance regressions. And the problem that we have is that we don't really have a lot of good visibility on just even generally how well the product performs at any scale. So as we've thought about this over the last few years, and as we've made all of these changes, we've attempted things, right? We've had some successes, we've had some failures. And so what we're going to talk about next is a brief history of performance tracking at Octopus. And I'm going to keep this pretty high level, and we're just going to share sort of the main things that we've tried to kind of get us to where we are now. So a little bit of context first. Octopus tends to be a pretty lean company. We're not huge. We don't have thousands of engineers. And so whenever we try to attempt a solution, we tend to try to do we try to go for like a high reusability or a co-opting type of approach. And so the first thing that we tried back in the day, this is a few years ago now, was we tried co-opting our end-to-end test framework. So what is the end-to-end test framework? It's a suite of tests that basically orchestrate complex behaviors, similar to like how a customer would use the product, basically. And the thing about the end-to-end test framework is that it's quite complex. And essentially what we do is we spin up like 6 or 8 instances of Octopus Server, and then we round robin them. And for each test, we say, cool, that one's available. Let's go and fire some requests at that server. And then we'll assert on some output from that. And so how we did this was we basically had a wrapper that sat on top of this really complex framework that would measure how long these requests took anytime we fired requests to the API. And again, this is on a machine that's got a lot of activity on it already, and so you're making these requests, singular requests, in ways that are basically locked into the design of the test itself. And you're making a single request. So the problem that we ran into was, first of all, it's like extremely difficult to maintain this thing, and it was very difficult to extend it. Because it's quite complex. It's fit for purpose. It's designed to be sort of a correctness test framework, and to sort of layer on top a performance element to that basically was just too difficult, frankly. And so, in addition to all the maintenance hassles, you had this high bias element where you've got all this noise on the machine. If you're doing performance tests or benchmarks, you're basically trying to assess for like how fast your code runs in the context of a machine that's basically, if you get the benchmark and you've got the actual server running on the same computer, there's contention for CPU cycles and that sort of thing. And so you get all this noise introduced into your data. And with a single sample, typically, you get into this scenario where it's like, okay, I can't even apply statistics to this to understand the distribution of those response times to figure out if we've actually got a real change or not. Okay, so since that was essentially too big of a mountain to climb, we bailed on that. Okay, and so the next thing that we tried at a high level was basically co-opting the integration test framework. And so similar to how the end-to-end test framework operates, the integration tests are a suite of tests that exercise specific components, specifically at the API level, typically, although we can reach in to the server if we really want to, but we tend to avoid that. And the approach that we took here was to try to basically create another wrapper over this this base class, essentially, that would start up an in-process, in-memory web server. And we used benchmark.net to facilitate the benchmarking. And so here we ran into another set of maintenance problems, as well as this kind of limitation around the statistics, which is like, it's kind of like the tests are generally designed to be pretty minimal. We're not looking to modify the test. We'll run the test multiple times, but we don't necessarily have a lot of state in the system to kind of give us that sort of like feeling of how well the system's operating when there's actual user-like behavior, because that's more or less what we're interested in. It doesn't need to be like a full, like enormous database necessarily, but we want to have some approximation here. And so the overarching issue here, like the theme is around the maintenance. Okay, it's like really difficult to maintain these systems. I think we introduced the benchmark.net approach back when, oh God, it would have been like a year and a half ago. I think it was when we were introducing .NET 5, and there were all these breaking changes in terms of how we were compiling Octopus Server. We were making major changes to how we even did that internally. Benchmark.net had its own issues with how it compiles and how it actually creates the jobs. And then, unfortunately, there were these limitations around user experience, like the dev experience using benchmark.net. It's a great benchmarking framework, of course. However, there's some limitations with respect to sort of this sort of application of that. In particular, it's kind of difficult to like debug tests and that sort of thing because they run out of process. which means that if you're running the test, you have to attach to like a completely separate thing. And it's not sort of in the one space you're working in inside of the IDE. If you're running sort of like a unit test, you can just debug that test. It's not quite the same with benchmark.net. So with all of these learnings and experiences, I kind of developed this vision around having a tool that was a little bit more, that was very much like benchmark.net, but a little bit more simple. It didn't have all of the hyper optimizations that library provides, but also, but did have sort of this, like a familiarity to it, I suppose. And so I came up with this idea of Sailfish, which is a benchmarking library. It allows you to write tests, so you can sort of see one of these example minimal tests over here on the right. If you're familiar with benchmark.net, this probably looks kind of familiar to you. It's modeled after that library. But it allows our developers to write tests in a way that is familiar and also like can be run directly in the IDE. So if you're interested in this, you can go to the documentation website, links over to GitHub if you're keen to have a look at the code. It's all open source, so feel free to have a look. But the main project goals here, I want to illustrate what these specific goals were. Right, the first thing was that I wanted to have a standard API for assembling performance benchmarks in the same way that like benchmark.net provides a standard API. I wanted to provide an experience similar to some of the common unit testing frameworks that are available to .NET developers, like XUnit or NUnit. And if you're familiar with unit testing in general, it's typically nice to be able to run these tests directly from your IDE. And so with Visual Studio or JetBrains Rider, you get these nice play buttons next to your test. And so that's what you get with Sailfish. And it also outputs, all the logged outputs come right into the test output window. So if there's exceptions, for example, when you're debugging or if you're running the test, or if it finishes completely, you get all the statistics printed out there and all the results. We'll have a look at what that looks like towards the end of the talk. Importantly, it also provides like a library that doesn't really require much maintenance because it's pure .NET code and it's very simple. So it's got a low maintenance overhead. But importantly, it enables usage as both a test project, like your XUnit or NUnit, but also as a library. And so what you can do with this is you can basically have a solution where you've got a couple of projects. I'm assuming that I'm talking to people who are familiar with sort of these things, but basically you can have two things sitting side by side: a project where you've got all of your tests, and you can develop those tests, you can run them directly in the IDE, you can configure them, you can do all the things that you need to do to get those tests running against whatever target. And then you can have a project that sits next to that serves as something like a CLI, where you can reference those tests, and then you can say containerize the CLI with the tests and then invoke it. So that gives us a lot of flexibility as both a good developer user experience, as well as something that can fit into a tracking system. And so that's what we get at Octopus from this library. Gives that familiar tool to our devs. So it's more or less really simple to develop one of these tests, but it also fits into a performance tracking system that we'll talk about next. Cool. Okay, now this is like what we're actually doing right now. And so this is pretty cool. The performance tracking system. Okay, so this tracking system is basically a multi-component system. It's a few microservices that run. And this diagram kind of expresses what the system looks like. It's all code, obviously, but hopefully this picture will suffice. Okay, so the way that this works, I'm gonna walk you through this diagram here. All right, so first we've got some sort of end user or some sort of trigger. Maybe we've got a user who wants to execute some tests against a particular version of Octopus Server, and they'll trigger the test via some UI or via a request. Or maybe we have a trigger that is in our CI pipeline. So this is how the system is currently being triggered. So what will happen is we'll make a request over to this test run orchestrator component. This is an API. It's just a web server that is responsible for orchestrating the runs, basically, and also keeping track of the data and then doing any analysis on that data. And so what will happen is the trigger will come in and the orchestrator will make a request to this other web server, the infrastructure controller. And this is a multi-purpose. This wasn't built specifically for the system. We've co-opted this component. But what this does is it allows us to stand up infrastructure in a cloud provider, like Azure, for example. And so when we make the request, it'll go and create some either containerized or non-containerized services. So for example, in this case, it'll go and create a resource group, and it'll use the Azure Container Service to spin up an Octopus server with a SQL server next to it, and then kind of wire these up together. And then credentials for accessing that server will be returned back through the controller down to the orchestrator. And so now we've got some infrastructure stood up, a live Octopus server instance ready to go. Maybe there's a backup database that's been restored. Maybe it's a fresh database. And then the orchestrator will say, great, now I've got these credentials for accessing the server. I'm going to pass those off to this Sailfish test runner. And so it'll invoke another container. So this is always going to be a containerized service, which holds the tests in the CLI that I mentioned before. And then it'll execute the tests. And that will make timed requests against the Octopus server. And once it finishes, it'll take the results, post them back to the orchestrator, save them into the database. And then the run ID, so this is all sort of like fire and forget. So as soon as you make the request, it'll return a run ID, and the end user or the system that's triggering it can poll for the completion of that run. And then when it's finished, they can either retrieve the raw data, or they can take a run from a previous run and compare it to the current run. And so this is how our tracking and analysis system, this is how we monitor for regressions. We say, cool, we had the run from before. That's this ID. And now we've got this ID for the run that we just did. I'm going to send those back to the orchestrator, and I'm going to ask it to analyze the two of those. And we'll employ various statistical methodologies as well as heuristics to determine whether or not there's an actual regression. And we'll layer in controls to assess for noise in the system and that sort of thing. And we're generally trying to achieve sort of an approximation of how well we're performing, as well as whether or not we have any major regressions coming through. And that's the system. That's pretty clever. I think that's pretty cool. Cool. All right. So I mentioned that all of this is in the cloud. Okay. So I think everybody here is probably going to be thinking, boy, geez, that seems kind of risky. There's going to be challenges associated with this. And you're right. There are some pretty significant challenges associated with assessing performance, in particular when you're using cloud infrastructure. And there certainly are going to be limitations to what you can actually achieve here. Okay, so as we talk about some of these challenges, the first thing I just want to kind of illustrate using my fantastic diagrams here is we have to ask the question first, like, what is the context in which we're benchmarking, assessing the performance? Okay, so when I think of APIs, I always think of like a sphere, and the sphere is it has these holes on the surface. Requests come in, a bunch of stuff happens inside, and then the request exits. And that sphere exists in the context of all of this, either the infrastructure on your local host or whatever. And so this diagram here is basically illustrating this to the best of my drawing abilities. I'm not really an artist, so forgive me for this. But anyway, these arrows coming in are arrows coming into these holes at the API surface. So all of the requests will come in through the feature space, and that's all the endpoints. And then what happens is, no matter what feature you're using, that request is going to pass through some sort of cross-cutting functionality. So whether it's the middleware, or whether it's the persistence layer to access some data in the database, or whether it's passing through the caching mechanism that's applied to a lot of our endpoints, or maybe there's a message bus or something like that. Like there's this cross-cutting features that are always going to be present in your API, and so these requests will always pass through those. And then this sort of behavior of the request sits inside of this broader context, pre-existing state in the database, for example. If you're going to go and scan a table, the amount of time it takes for that request and response to complete is going to be contingent on how much data is in a particular table when you need to scan the table. If there's more data in the table, it may take longer to get through that. And then there's background activity. So I mentioned the task system that we have in Octopus Server previously. There's a lot of background tasks actually that are going on. And depending on how much activity there is, different users coming in and doing things on the server, which background tasks are enabled, how much data there is to process within each of those tasks can affect the response time. This, of course, sits within this network situation. These requests have to be made across networks, which then sits inside of this broader infrastructure context, the machines themselves and the providers of those machines. And so let's talk a little bit about the biases from this infrastructure. Okay, we're not going to go through an exhaustive list. I mean, that's not the point here. The point is to just kind of share, hey, there's a lot of things, and this is just a few of them. And you'll notice that a lot of these are out of our control. So for example, resource sharing. You know, you have to be deliberate about how you choose the machines that your software is going to run on, right? The Octopus server instance. Can you, how much can you control for noise in that aspect of the system? Physical location. If I'm making a request from Melbourne, so I'm in Australia at the moment, Melbourne to Sydney, that request might return a little bit quicker than if I'm making a request from Melbourne to London, say, or New York, or what have you. So physical location comes into play. Thermal throttling can get you. When computers get hot, they slow down a little bit, right? It's not much you can do about that. Network bandwidth limits. Cloud providers enforce their own limits across a lot of their features. A lot of their features. There's network path variation, disk I/O performance, CPU and memory type, virtualization overhead, security layers, encryption, that sort of thing. List goes on and on and on. So all of these can introduce bias into your results, which you have to either mitigate or control for. So this image here, I'm going to share a couple of plots in this talk. So this image here is demonstrative of this sort of noise that you might experience. So what we did as part of this sort of proof of concept, I suppose, is we built a minimal system and then we stressed it like crazy. And we ran, I think it was like 15 performance tests not in parallel, but like individual. We stood up, I guess, 15 resource groups, you might say, and then invoked 15 different test suites against those. And we did this, I think, around 1,800 times. Let's call it 2,000 times. And so each line here, so there's one line here you can see. Each of these little blops here are lines, vertical lines. And what you're looking at is the standard deviation, one standard deviation for the distribution that is returned for each of these tests. And so what that means is, we have a test, we execute it 15 times. We've got an array of 15 numbers, that's our distribution. And then I can look at the standard deviation of that distribution. And so typically, this is one of our control tests where we're just looking at, it's like a thread.sleep or something like that on the machine in the test. That's all we're doing. And you can see here, typically, it completes pretty much instantly, which is what you'd want to see for this control. But every once in a while, we get struck by a meteor, So I think this happened one time in 2,000 tests. So what's the chance of being hit by a meteor in this context, where suddenly we're waiting around 50 milliseconds? For no good reason, really. It's about 1 in 2,000. Okay. Our system needs to be able to mitigate that or handle that or recognize when that happens, because this might lead to something called a false positive. And that's something we really want to avoid when we're trying to give our developers feedback on whether or not their code changes are slowing the product down. So the system is not the only thing of concern for us, of course. We also have to think about the product itself. And so what we have to do is assess application behavior biases. Unfortunately, the reality here is, I've written here, not all tests are created equal or suitable for automated tracking. And so hopefully you can see the tiny text here. It's not really too important. The idea is that we've got 6 individual tests that we've analyzed. So this is part of that experiment where we've sampled the system, thousands of times. And then for each of the 2,000 runs, we've collected all the results from that and plotted out a distribution of the entire range of response times we might get for this test, just to get a sense of, can we even use this test or this set of tests that we've already established? So I'm going to draw your attention away from this first one. We'll come back to this in a second. But the things I want to point out here are that typically we've got a single peak for most of these tests. And oftentimes the distribution, the range of minimum to max runtime value. So you see here on the x-axis, we've got the runtime for the test. This is all in milliseconds. It's a histogram, so the y-axis is just the frequency for that particular bin. But you can see, like, typically for this test, we're around maybe 200, 180 milliseconds. But every so often, we get up to about 400 milliseconds. Okay. So that's a problem that we need to deal with in the system when we're analyzing for regressions, because this is against the same version of server over and over again. This is the actual distribution of response times. And so if we've got a sample that falls within this distribution, it very well may be a real result and may not be a regression. So we need to be careful. You've also got, so we'll go back to this first test here, because this is really interesting. You've also got some of these behaviors in server, which are, quite frankly, somewhat surprising. We've got 2 peaks instead of 1 peak. So this is what's called a bimodal distribution. And so that means that the system generating the data, server plus all the infrastructure and everything, has 2 modes of operation for this test. Sometimes it runs kind of slow, maybe between 40 seconds and 60 seconds. And that's to create 10 machines in Octopus server. And then sometimes it runs faster. Not as frequently, but just sometimes it just runs faster. And so if we're sampling from this distribution, sometimes we might sample from this mode around 20 seconds, 25 seconds. And then sometimes we might sample from this distribution, maybe around 60 seconds. 20 seconds to 60 seconds might seem like a regression, but in the context of the real distribution for this particular test, it's actually not. And so we can't really use tests like this that have bimodality, multimodal tests. But at the same time, the big picture here is like we can't really. It's about sensitivity, really. Like how sensitive can we be in detecting a regression? Cool. Okay. So ultimately, once we've curated our tests and we've got the system working and it's firing against every commit or every version that we try to ship, what does this give us? What are the impacts of this and benefits? So the first thing is that we get visibility and trends. This is really important. We can see kind of the performance for each individual test. And again, we're focusing on these cross-cutting, if I haven't emphasized this strongly enough, we're really focusing on the cross-cutting concerns of the product. So we're not so interested in I think it's like 400 different endpoints. We're not going to try to cover that because that's a maintenance nightmare in and of itself. We're going to really just have a few tests that focus on exercising the core functionality, the cross-cutting functionality of the server, the caching mechanisms, the persistence abstractions, these sorts of things. And we get insights on whether or not we are breaking this for regressing in these components. And then we can also create some safety nets around the core functionality as well. So we can get some notifications if and when a clear regression is introduced that slows the product down. And so on the right here, you can see some plots that we've got in one of our internal dashboards. It gives us insight into one of our deployment preview endpoints. So this is one of our hidden endpoints, but you can see that we are stable over versions. So these are the different versions. And I think this is the last 50 versions or so, give or take. So that's what it gets. And the visibility thing is really important as well, because like I mentioned earlier, we had some changes to our caching mechanisms. And it's not just that we were able to detect the regression, right? The power behind this is that we could see that we could test the change. We had a version of server where some changes to the caching mechanism were made. We exercised the test suite against that new version. And then we were able to compare before and after that change, and we could see what the actual difference was after drawing many samples. And then we could make an educated decision, a strategic decision around whether or not we were willing to accept that change. Ultimately, we were, right? And the point is we were able to see that and actually have the information we need to make the decision. And that's what's key. Cool. Okay, so that's the tracking system, right? That's around speed. Now I want to talk a little bit about scalability. Okay, so this is going to be around assessing scalability using machine learning. I think this is particularly exciting, so I hope you find this exciting as well. And what we're going to do, I'm not just in general, we're not here to give a lecture on machine learning or anything like that. I think it's a fascinating tool in our toolkit that we can leverage. But what I want to do here is give an example of how we can use machine learning to assess scalability. So we're going to walk through sort of the steps that we took to kind of produce a result. And the question that we're going to ask is, how well do tenanted deployments scale? Okay, so the technique we're going to use is first model selection. There's two techniques. One is model selection. We're going to assess the complexity of this particular behavior, I suppose. It's not a single endpoint, but it is actually. So we're going to assess whether or not its complexity is linear as it scales. Do we experience linear growth or log n growth or quadratic growth, things like that. And then once we have a model selected, we're going to perform regression to create a model that we can use to make predictions. Okay, so we'll see exactly what I mean by all this in just a second. The data that we're going to use are sailfish execution results. And there are a couple of caveats. Okay. So first thought is that this is a non-rigorous example. Okay, so this is a real experiment that I did. I did do it for the purpose of the talk, but we're probably going to use it as well internally. We may redo the experiment, but what I mean by non-rigorous is, I wasn't super careful around turning off all the other processes on my computer or getting a very clean machine to do this on, making sure there's like very minimal noise and that sort of thing. But we did take a lot of samples, as we'll see in a moment, and we did perform outlier detection and remove those. And so it is a pretty stable data set, and we'll see what it looks like in just a moment. The other caveat is the data from this particular experiment tends to be heteroscedastic. So that's a crazy word. What does that mean? It means basically that we can be less certain about our predictions at higher scales. In technical terms, it means as your as your x value on your plot, as your x value increases, the standard deviation of your data tends to increase. We'll have a visualization of what that looks like. And so the other thing is that this is based on simulations run on my local computer, so my laptop. It doesn't account for things like the auto-scaling infrastructure that our cloud platform has for Octopus Server and all that sort of, all those bells and whistles. This is just like on my machine, when I'm running a single instance, not a cluster of Octopus Server on my laptop, how well does this scale? All right, so those are the caveats. Alrighty, so the first thing was to write some tests. I'm not going to show you the code for the test because it's kind of just like code, I suppose, and we're not going to talk through that anyways. But to give you a sense of what Sailfish looks like when you're using it in the IDE, if you're familiar with JetBrains Rider when you're running unit tests, you can see it looks pretty familiar, right? We've got all the tests here, and we can see the scale that we're running at. So when there's one tenanted, one tenant for the tenanted deployment, that's a tongue twister right there, I think. I think there's 5, there's 10, 20 tenants, 50 tenants, and 100 tenants. You can see the outputs from one of these tests below. We've got some descriptive statistics, the mean, median, the standard deviation, the min and the max. We've got the outliers presented here, as well as the distribution. So these are actually the actual results from the tests. So basically we did some setup, and then we said, great, we've got one tenant, deploy to that tenant. Cool, create 4 more tenants. Now we've got 5 tenants, deploy to all 5 of those tenants, and do that 50 times, right? And keep track of how long it takes. And that's what these numbers down here represent. So we ran this over and over again. That's something you can do with Sailfish. Okay, so once we've got the data, we can then have a look at the result. So the first thing that we did is plotted what's called a kernel density estimation plot. So that's another fancy word, I suppose, in statistics land. But basically what it means is, what's the distribution look like for your data? So as I mentioned before, our data is heteroscedastic. And what that means is that when we're at small values over to the left, so you can see the blue here is 1 tenant, over on the right is 100 tenants, and it's just 1, 5, 10, 20, 50, and 100. That's what each of these peaks are. On the left side, we have really tight distributions. There's not a lot of spread. But as we get higher and higher in the scale, we tend to flatten out and be less certain about where the actual value is. We have a wider range of response values for this. And so you can imagine as you continue to move up and up and up in scale, it'll just get wider and wider. And so your confidence decreases as you increase your scale. Okay, so that's a limitation, unfortunately. But we'll see in the next plot that it's not such a bad thing. It's not so limiting. I guess the next slide, I suppose, because the next thing we're doing actually is model selection. So we run our, there's a feature in Sailfish called Scalefish. So yeah, that's that's a thing. Anyway, Scalefish helps you perform model selection based on results like this. Okay, so this is what one of the outputs from Scalefish looks like. We've got our tenanted deployments. And essentially what I want you to focus on here is just the best fit. It's a linear growth model. That was the best fitting model that we found. And then you can see the goodness of fit metric. And then we've got the next best goodness of fit that you can see over here. And you can see it's pretty close, but not quite as good as the linear model. And so what we'll do is we're automatically perform the regression. So this kind of happens at the same time, technically, model selection and the regression, because it's the regression that allows us to select the model to produce the goodness of fit measure. But the actual model that this produced is right here. And I think probably most of you will be familiar with the form of this model. F of x equals mx plus b, right? It's just your high school algebra, really. The machine learning component to this is that we're able to learn what this number here before the x is, and then what this negative number over here is. So that's the learning bit. And so we're able to regress and achieve a model that is f of x equals 67.16 times x minus 716.46. Cool. All right, now if I want to make a prediction, all I need to do is take my scale into account. Say I measured up to 100. Maybe I want to predict 1,000. I plug 1,000 in for x, and then that's my result. And so what does this look like? If I plot things out, this is a plot of linear growth and runtime for tenanted deployments. My duration here is on the left. So that's my y-axis, 20 seconds, 40 seconds, 60 seconds. And then on the x-axis is the number of deployments. And so each of these violin plots That's what these are called. They show the distribution of results at that particular scale. My line was basically fit through these, and you can see it's not perfect. It's not right through the center. It's not exactly through the center, but it's pretty close. It's the best fit line that we could produce during this regression. And so once I've got this line, I can say, great, I know exactly how this is going to scale. It's linear, thank goodness. And then, yeah, we'll just plug the numbers in. And that's what this is here. Cool. All right, so what are some actual predictions that we've made? I think this is like really, really cool. So I'm geeking out a little bit talking about this. All right, so for 300 tenants, for example, we'd expect that to take about 7 minutes. So we saw on the last slide, I'm gonna actually go back really quickly. For maybe 50 tenants, it took about, I don't know, 70 seconds or so. For 100 tenants, it took on average about 150 seconds. Okay. So if I scale that up to 300 tenants, well, then it was probably going to be, plus or minus a few minutes, about 7 minutes. 500 tenants, it might take about 12 minutes. At 1,000 tenants, maybe around half an hour, plus or minus 10 minutes or so, something like that. 10,000 tenants, now we're getting into the 4+ hour range, plus or minus. Let's say we want to get up to 50,000, because that's one of our key objectives, is like we're trying to support 50,000 things, 50,000 tenants. Can we get the system in a state where we can support this? And so I think that the real, how do I want to articulate this? Like the power behind this, like what makes this so useful, is that it's not just about us knowing whether or not we can scale. It helps us understand what kind of promises we can bring, right? If we have a customer that says, "Hey, Octopus Deploy, we need to do 100,000 deployments in 24 hours, like every single day. We have to deploy our software to 100,000 tenants. Can you do this?" We can look, instead of spending 24 hours to actually do that, to see if we can, or longer if we actually can't, what we can do is use machine learning to make predictions about this. And we can say, well, based on these predictions and our confidence, it looks like if we do 100,000 deployments, it's going to take us around 40 hours. So we're probably not ready to take that on quite yet. But depending on how much you pay us, we can talk priorities, right? Or something to that effect. But anyway, that's kind of the utility here, which I find really interesting and quite exciting. Okay, so I'll finish this up by saying, just reminding that these are predictions, so they're approximations. If we did 50,000 tenanted deployments, would it actually take 20 hours? Probably not, because we're drawing from a sample. We know approximately how much time it should take. But I do think that it serves as a decent starting point, both for conversations with customers, as well as internally to understand our own product and how well we scale. Cool. All right, well, that's it from me. Thank you so much for hanging out. I hope you've been enjoying this event. I think it's pretty exciting for all of us internally. So thank you so much for spending the time to listen to what I have to say. If you have any questions, feel free to reach out. You can, find us somewhere. I'm on LinkedIn. You can contact the company and that sort of thing. But yeah, enjoy the rest of the event, and hopefully we'll see you in person at the next one.
Hey everyone, hope you're enjoying SHIPPED23. We're in the home stretch now, so you've almost made it to the end. Congratulations. We're going to take another 10-minute break here, so feel free to stretch your legs, grab a drink, grab something to eat, and we'll be back in just a second.
Hi, everyone. It's lovely to meet you all. By way of introduction, my name is Ian, and I'm a Senior Product Manager here at Octopus Deploy. Welcome to SHIPPED23. I'm currently at the Octopus Deploy office. Hopefully you can see the little tentacle in the background, which is a big feature of the office here. And yeah, really excited to be chatting with all of you today about multi-tenancy. So today, a lot of my presentation is going to be all about the new, wonderful, and powerful features we've brought to our unique and first-class multi-tenancy feature in Octopus. Tenants in Octopus is one way in which you can model your deployments. And for some of our new and existing customers, it's the only way that teams can visualize and execute their deployments in Octopus. So really excited to be speaking here with you today. And yeah, just can't wait to show you all the good stuff that we've been working here on multi-tenancy. Yeah, so just a quick shout out to the team before I start off. So as mentioned, I'm a senior product manager here, and the team that I am currently working in is called the Modeling at Scale team. And these are all the lovely team members that we have, and they're primarily responsible for releasing all of the new features that I will be showcasing today. So just wanted to give a big shout out to the team, and and just wanted to sort of highlight the success of the team members in shipping all the great stuff that we've done this year. Awesome. So this is the agenda that we'll walk through for today's seminar. So firstly, we'll just walk through sort of what is multi-tenancy in Octopus. Sometimes the terms can be sort of conflated or sort of misunderstood directly with other sort of common terms around tenants in the DevOps world. So I just want to really highlight what we think about multi-tenancy and how that works for us in Octopus. I'll also go through some of the benefits of using multi-tenancy in Octopus and how you can use Octopus in order to supercharge your multi-tenanted deployments. And then we'll finally get to some of the good stuff, which is around the new features that the team has been working on and have shipped for the multi-tenancy features. So for example, a new overview dashboard for multi-tenancy, a couple of bolt actions in order to quickly onboard your teams onto Octopus around tenants and projects. And finally, a really exciting new bulk deployments feature that really speeds up a lot of deployments that you have to thousands and thousands of tenants that you may one day host on Octopus. So first off, what I really want to talk about is what is multi-tenancy in Octopus? And again, the reason why I want to sort of talk about this is because there's sometimes a couple of ways in which this term can be used. Sometimes folks are a bit confused by what tenants are, and I just really want to take the time to explain how we think about it in Octopus. Before that, basically, we must understand like what projects are in Octopus, what we consider as projects in our product. So at a basic level, what we mean by projects is that it represents a deployment configuration for an application. One of the key pieces of the deployment configuration is the deployment process itself, which can be set up in Octopus. So for example, here what you're seeing is a step-by-step deployment process that you can very easily define and configure, and really easily and have a really visual way to sort of see different steps of your deployment process. And the way that we've set it up Octopus is that these are the sort of steps that you got to take, and it must be performed in a very specific order for your deployment process to ultimately succeed. And basically what it is that the deployment process can be defined once per application and then reused across testing and production environments. So let's say, for example, we worked at a retail store, and we had an application that was used by our customers to make purchasing decisions within the store itself. Now, typically what that means is that to ensure that customers are browsing the inventory that's local to the store, we would have a copy of each application at each location running on the servers in the store to provide the best possible experience. The process in which we would need to deploy that application doesn't change. The only thing that's really going to change are minor configuration items, such as the name that's displayed at the top of the screen, as well as the various connections to databases or other services. Essentially, what this means is that this is where the multi-tenancy feature in Octopus can really benefit your team and help scale that deployment process to hundreds of thousands of stores, or in the Octopus world, the stores are the tenants. So physical locations like what I just walked through is a very common scenario if you run software in brick and mortar locations. You may need separate deployments because each site has its own needs, like time zones, outage windows, and technology. But Octopus allows you to deploy to all physical locations and meet those needs without duplicating the effort. And another example is isolated infrastructure for each of your SaaS customers. So in this scenario, you host a SaaS or a PaaS platform, and many customers access it in their own instance, which is very common for many SaaS platforms. And basically what it is that Octopus's tenants feature lets you define your process once and deploy to each customer instance almost immediately. That is because tenants are a predefined group of application hosts. And when we talk about what we mean by tenants, is that some of the examples can be retail stores, branch offices, your customer infrastructure, as we mentioned in that sort of SaaS or PaaS scenario. And this is especially if the Octopus user is a B2B provider and you need to deploy to your customer's infrastructure, or you need to deploy to an isolated cloud infrastructure per customer, and maybe it's a different cloud region for a variety of different legal reasons. This can also represent data centers. So, for example, a data center is located in Salt Lake City, and another is located in Austin, Texas, and another is located in Brisbane, Australia, which is where the Octopus Deploy office is. Then they will have slightly different configurations, but generally the process needs to be the same. Or last but not least, they can also be an isolated testing lab in which you might be deploying to physical hardware, and they need to be able to support a variety of different hardware configurations. So there is a testing lab that represents the different configurations, essentially. Basically, the most important thing to understand is that the host for each of these tenants runs a copy of the application on the predefined group of hosts, but they require slightly different configurations. As such, multi-tenancy in Octopus Deploy allows you to scale a single deployment process to hundreds or even thousands of different tenants. And you can define your deployment process just once, and it can be used as many times as you want to deploy to all of your related tenants. This makes deployment and configuration at scale easy and simple for your team, and allows you to replicate your deployment process with little to no fuss at the same time. All right, now that we've talked a little bit about the background of multi-tenancy in Octopus and how we take a look at it, what I'd like to sort of cover off next are some of the benefits that you can expect, or some of what our customers currently are experiencing of using multi-tenancy in Octopus. So one of the key benefits of using multi-tenancy in Octopus is the ability to release across environments. So using Octopus, you can manage your tenanted deployments how it best suits you and your team. You're able to deploy to one tenant, some tenant, or all of your tenants at once, or for specific release rings based on defined tenant tags. Another benefit of using multi-tenancy in Octopus is that, again, as mentioned, you're able to define your deployment process just once, and then use that to seamlessly connect to either side of your deployment pipeline and use it for as many customers or locations as you need. And you can manage each of your tenants' unique processes, customizations, and features using, again, tenant tags and variables as well. Another benefit of it is that you're able to configure variables for each tenant. So you can define your variable values like database connection strings or API keys. They're different for each tenant in your project. So still being able to use the single deployment process, but using variables to really have that powerful configuration and powerful flexibility in order to define different sort of deployment processes for different tenants. And finally, you can also create tenants and perform routine tasks with ease. So you can use this. You can do this using our runbooks feature essentially. So you can use runbooks to sort of automate tenants and infrastructure provisioning whenever you need. You can sort of manage your backups, your database maintenance, and service failover and restoration with one click. And I know I said finally just now, but then I realized I had another slide. So this is actually the final slide on the benefits, which is you're able to monitor your tenanted deployments pretty easily in Octopus as well. So this is a little bit of a sneak peek to some of the new features that we have coming up. But using our dashboard or single pane of glass, you will know where your releases are regardless of your multi-tenancy strategy. You're able to sort of see key information about your tenants at a glance, just for example, like the projects they belong to, the assigned tenant tags, as well as the environments for each of your tenants. Awesome. So now we get to the good stuff. So for this next part of the presentation, what I'd like to do is to walk through a couple of the new features that we've released for multi-tenancy in Octopus that the team's been hard at work this year. And a lot of what we've been working on, really, if I could just sum it up, is to improve the visibility, management, as well as the speed at which users can really sort of navigate through their tenants as well as perform deployments to their tenants. And the first feature that I'd like to sort of talk about is the new tenant overview dashboard that we've released earlier this year. This is what the old tenant overview dashboard looked like. It was basically a card-based dashboard where essentially each of these cards that you see on this dashboard denotes a different tenant. So what we would have is basically the tenant logo, if you had one, the tenant name as well. And if you can see those little colored boxes underneath the tenant name, that's what we use to denote tenant tags. And when the tenants feature was first released in Octopus, this was fine because a lot of our customers started using tenants in Octopus, and hey, they would maybe have 10 tenants, 20 tenants, 30 tenants, and so they weren't really using sort of hundreds or thousands of tenants. They usually had a very small pool of tenants when they first started. But as our customers really understood the benefits of multi-tenancy in Octopus and really started scaling up the number of tenants that they had in Octopus, this dashboard just didn't cut it. It didn't give them the information that they were looking for at a glance, particularly around the projects that they were connected to or what the tags really were. It really didn't give them enough information, especially about the environments that they may be connected to as well. And so it didn't really just give that visibility at scale, of understanding, the state of your tenants, as well as what were the different configurations that were attached to your tenants, whether they were projects or tags or environments. And so we're quite happy to say that, hey, this is something that we've fixed this year, or something that we've helped to elevate this year through our new tenant overview dashboard. So I'd be more than happy to sort of walk through what this looks like in the demo instance, which I will be switching to right now. All right, so here we are on the Octopus Deploy demo instance, and what you're seeing here is the space level dashboard, which is where most, if not all, of our Octopus users will land when they first get into Octopus. And in order to access our new Tenants Overview dashboard, all you have to do is to go to this top menu, top nav bar menu item here called Tenants, and here we go. We are at the new Tenant Overview dashboard. So what's new with this dashboard is, as you can see, we've sort of totally redid the dashboard from the ground up, ripped up the card space dashboard that you saw earlier, and basically the first thing is that we've implemented a new data table here. So and in this data table, the information that we're displaying here is the tenant name, the tenant tag, the projects that are connected to that tenant, as well as the environments that are connected to that particular tenant as well. So as you can see at a glance already, you're able to see a lot more information about your tenants, as well as all the important associated items that you might be interested in with respect to your tenants. So another cool feature about this new dashboard are the filters. So as you can see here, we've got a bunch of filters here, which are essentially rules-based filters. So in the previous dashboard, what we had was we still had a filtering system in the old dashboard, but you weren't able to sort of build sort of powerful rules that were able to include or exclude certain things that you might be searching about your tenant. So for example, here, if we can just show, so I can do something like, all right, I want to be able to look for a tenant that is maybe connected to this Formula One app. Project, right? So, filtered by project is Formula One app. And as you can see, we're showing 70 of 272 tenants that are associated with Formula One app. We can also do exclusionary filters here now, which was something that we didn't have previously. So for example, we could have project is not Formula One app. And as you can see, that's the opposite of obviously what was shown. So it's showing 70 of 272 before, and now it's showing 202 of 272. So the inclusion and exclusionary filters are quite powerful for users that are trying to filter through thousands of tenants, because it allows them to exclude certain characteristics of tenants that they're not looking for, and maybe include certain characteristics that they are looking for. And again, because this is rules-based, we can actually start stacking these rules together in order to have a really good granular view of the kind of tenants that we're looking for. So for example, let's say I am looking for a tenant that is connected to Project Is Formula One app. And then maybe, I'm like, all right, cool. I actually want to see, what kind of tag they're associated with as well. So for example, we could filter it by, this tag set's called another tag set, but we can filter it by a tag set and select particular tags in which they can be associated with. So for example, maybe I'm looking for a tenant that is associated with test tag 1. And it comes up with Amber Bracket essentially. Or maybe you're not looking for something that's associated with test tag 1, and as you can see, that's taken out the tenant that's associated with that as well. And so so using our new rules-based filters, we're able to really dive deeper into certain tenants that we're looking for, and really define what you're actually looking for. So it really improves the navigation and the findability and searchability of specific tenants. And when you are applying the rules, what's great is that we provide you a little summary at the top here of what are the rules that you're actually attaching together, the number of different characteristics that you might be attaching to it, and just gives you that just better detail in terms of what you're searching for. So that's pretty neat in terms of the new filter, searchability, and navigation. You're also able to actually share filters. So for example, if let's go back to project is Formula One app, and maybe you're like, oh, actually, I found the tenant. It was Amber Brocket that I was looking for. And what you can do is that if you have a team member that's like, hey, I've actually been looking for the Amber Brocket tenant, or I've been looking for tenants that fulfill this particular criteria. Can you please share, the search criteria, search filters with me? You can just hit the share filter, and what this is a deep link URL that you can copy to clipboard and basically share it to them in, Slack, Microsoft Teams, or even an email. If anyone still uses email, I'm sure everyone does. But essentially, you're able to really easily share this information across, and really, helps to bring your teammates up to speed in terms of the tenant that you looked for, or to help them look for the particular tenant that they wanted to look for. And the final thing I wanted to talk about the filters here is that you're able to download this as a CSV. So the CSV downloads what you see, what you get. So essentially, for example, if I were to leave it like this, and there are 272 tenants here, and I downloaded this CSV, it would just download, what the tenants were, what the tenant tags that are associated with the tenants, the projects, and the environments. If I were to, again, apply the same filters as before, so Formula One app, and another tag set is tag 2, and it's Amber Brocket, and I clicked download CSV, that would only download the Amber Brocket information. So the tenant name Amber Brocket, tenant tag associated with Amber Brocket, projects associated with Amber Brocket. You get the point. I am repeating Amber Brocket quite a bit. So so that's pretty neat. And again, that's all helps with a lot of sort of data management for our customers who, maybe they just want to be able to have an Excel view of everything that they want to see, and having all of these things basically unbounded or outside of the collapsible rows in Excel, and just allows them to see that data much clearer, perhaps outside on a spreadsheet sort of tool. Awesome. A couple more things about this dashboard that I'd love to chat about. So for example, as you can see here, and as I've already mentioned, we do have collapsible rows. And the purpose of these collapsible rows is obviously to keep it pretty neat and tidy in terms of the information that you're looking for about the tenant. But let's say, you really want to, you've come to Beige Elk, and you're like, hey, I really want to be able to see what these, +5 projects, or what these environments that they're connected with. You can simply just open this, and now you're able to see essentially, all of the different projects that are connected to Beige Elk, as well as all the different tenant tags that are associated with Beige Elk. As well as obviously the tenant tags, which we've only got one here for now. So again, this really helps with, not just keeping the table neat, but really giving customers the option of, if there is additional information that you want to see, that it is available at a glance or at a click in this case. And that you're able to access the information with little to no hassle. And finally, what I want to talk about this table is that, we've got pagination controls here. So the previous tenant dashboard had no pagination. And that was fine when you had up to, again, as mentioned, 50 to 60 tenants. But once you get past that level, probably you'd require some level of pagination and or results control to ensure that, the dashboard isn't getting too unwieldy, and that, you're not having too many tenants on the page at the same time. So you're able to scroll through the different tenants using the pagination controls. And you're also able to show different results per page. So for example, at the moment, I've got 30 tenants per page. We can go up to 50 tenants, so you're able to see a lot more at a glance if you so require. Or, for our power users, and they really want to see all these tenants, you can go up to 100 a page and basically, see 100 tenants at the same time for whatever reasons that you might have to see 100 tenants at the same time. Awesome. Cool. So that's what I wanted to show in terms of the new tenant overview dashboard. And again, a lot of the work that we've done here is to really solve that user problem around visibility at scale, navigation at scale, and findability at scale, especially when we're talking about tenants. And you can have so many different things associated with tenants, such as projects, environments, and tags, and previously difficult to see them, difficult to really manage them, difficult to really understand the relationships that tenants might have to different projects, tags, as well as environments. But here on this dashboard, we've really brought all the concepts together in one single pane of glass, and really helps users who, existing users of multi-tenancy, new users of multi-tenancy, or even anyone that's in existing, but they might have joined the company and be like, hey, what are our tenants and how are they associated with all the different things that we might have in our instance. Having a dashboard like this and the powerful way in which you can view and find things really helps them also onboard onto the tenants feature and really understand the value that tenants can bring to the Octopus instance. So that's what I wanted to talk about with the tenant overview dashboard. And the next feature that we'll talk about is bulk actions to connect tenants and projects. So this is what it is over here, and I wish I had a screenshot of what it was previously, but unfortunately we've updated all our Octopus cloud instances and stuff, so I don't have that. But essentially, how we used to connect tenants and projects can all be boiled down to this. Let's say you had, let's take the SaaS example, right? So let's say you work in a product, and you white label it for maybe 10 different customers at the moment. Let's just say you do that. And let's say, your company signs a new contract and they're like, hey, we've got 10 other customers that want to use our product. Let's hook them up as tenants in Octopus. And once you do that, we need to maybe deploy a product to them today or something like that. So what tended to happen before we had the bulk actions was that you had to actually do that one by one. So you had to create a new tenant and then go into that tenant, connect it to an existing project, get out of that tenant, create another new tenant, and then go into another, the existing project, connect that. So it was a very singular based action. It was a very time wasteful action. It was very administrative and heavy and very manual, essentially, where it just didn't make sense that we have customers that currently in Octopus, they have thousands of tenants or thousands of projects, and so when they create a new tenant or they create a new project, they are looking, they're facing the fact that they have to actually connect each of these projects, each of these tenants one by one to existing projects or tenants. And it can take a lot of time, and folks don't want to do that. They want to make sure that a lot of it's as automated as can be, or to cut down a lot of manual time that they're running around with these administrative tasks in Octopus, because they want to focus, they want to shift focus to what they prefer to be focusing on, which is defining their deployment process and ensuring that their deployments are getting out to their tenants. So we've made it a lot easier to onboard new tenants or new projects into Octopus using the new bulk actions that we have. So I will now flick back over into the demo instance to show you what that bulk action looks like. Cool. So let's say again, let's start off with the projects with multiple tenants, which I think would be a lot more relevant to a lot of folks. So for example, let's say like, hey, we've got a couple of new tenants and we want to connect them up to a project. This project has all the tenants. So let me find yes, that's right. This is the project I created for Shipped. As you can see, we try to be as seamless as possible with these demos, but then too many projects and I couldn't find it. So let's just say, hey, we've got a new SHIPPED23 project, right? And we're like, okay, we need to connect this up to all of our existing tenants. Again, as mentioned, what you would have had to do previously was that you had to sort of connect it one by one. So imagine connecting, I've only got 260 tenants in this instance, for example. Let's say you've got thousands, which some of our customers are running. You have to do that one by one. And basically that could be your whole morning or even your whole day, depending on, how your index finger is feeling after connecting 100 tenants one by one. But now we've made it a lot easier. So for example, let's say I want to connect all 263 tenants to this SHIPPED23 project. All I got to do is hit this. And what you have now is this beautiful wizard, which sort of shows you on the left-hand side all of the tenants that are in this instance and available to connect to your specific project. And on this right-hand side of the window, what it is that when you start selecting your tenants, so for example, we can select a couple of these tenants here, it'll show you the fact that, okay, you've selected these tenants to actually connect to this project. So depending on how many tenants you want to connect, as mentioned, you can connect, a couple that maybe you're like, okay, these are the ones that I know I want to connect to this project. Or what happens more often than not is that a lot of our customers are actually connecting all their tenants to a new project or existing project that may not have these tenants. So when you want to do that, all you got to do is select all 272 tenants, and voila, it's all on this side of the screen, basically. A couple of things that I want to point out here is that, for example, we've also included filters here. So very similar to the filters that we had in the tenant overview dashboard, where, for example, you can build rules. And essentially, we are only allowed to build rules around tenant tags here because through our customer research and through folks that we're talking about, a lot of customers are saying that the way that they would select tenants for this bulk action is to only just use tenant tags. So we've only focused on ensuring that you're able to filter by tenant tags, but still ensuring that you still have that really powerful rules-based way of doing it. So for example, what I mean by that is that, you might be selecting customers in, for example, Basher and Abbott, for example. And again, you can be either inclusionary with the filter. So for example, these can be customers that have Basher and Abbott as their tenant tag, or not in the Bashirian habit. So for example, that sort of, as you can see, there were 10 previously, and now there's 262. And that just depends on whether or not you put in or not in a particular tenant tag or tenant tag set. And, for sometimes you'd have tenants that have multiple tenant tags. So for example, maybe you'd have a tenant that is, you have a tenant tag specifying the geographical region in which they're in. So for example, maybe they're in Salt Lake City or Brisbane, for example, and then maybe you'd also define them under a second tenant tag, such as the industry that they operate in. So, for example, whether it's manufacturing, whether it's tech. So you could do that as well, where you could do customers not in Basher and Abbott, and then another tag set, which is another tenant tag set, or customer in test tag 1. And now what you see here is that these are the tenants that are specifically having both the Basher and Abbott tag, as well as test tag 1. So again, we're bringing still the powerful way in which you can find and filter tenants via multiple selection of tenant tags, and building those multiple selections into rules-based filters that really helps you just scope down and narrow down the tenant that you're looking for. So that's the filters and how that works. And again, as mentioned, we have pagination here just for better data control and sort of better. It just looks a lot neater on this window as well. But let's say, for example, okay, I want to connect all 292 tenants here, 272 tenants here. And what I'll do is that I'll hit next. And what you can do here is basically, again, you can select different environments. So theoretically speaking, when you use multi-tenancy, a lot of our customers are using a one-to-one relationship between tenants and environments. So for example, you'll have a dev tenant or a staging tenant and a production tenant, but sometimes you never ever have sort of a dev, staging, and production tenant. That's just not the way that it sort of works. Usually a production tenant is like, you're pushing packages directly to like a machine, a hospital machine, for example, like MRI machine or something like that. But sometimes for some of our customers, they do have sometimes requirements where their production tenants also requires a testing environment. So maybe it'll be like test to production. And so that's why we give the flexibility in terms of, hey, when you do have that unique scenario, maybe not all of your tenants are production tenants, but maybe they do have a dev and a staging environment. Dev and production environment for your tenants. So we give you the option of, hey, being able to do as you will with tenants and attach 2 environments or even 3 environments or 4 environments, basically attach environments to to your heart's content to all of the tenants that you want to. So you can do that, or if you do traditionally just having production tenants or dev tenants or staging tenants, just being able to select one and having that apply to all of your tenants, assuming these are all dev tenants, then you're able to do that as well. But let's say I'm like, all right, we're power users, we really love attaching a lot of environments to our tenants. Let's assign all available environments, so you're able to do that as well. And the great thing about this is that we really give you a call out. You're able to connect about 272 tenants to this project. We're giving you a little pane of glass to review your connection, so that you're not caught unawares with like, hey, maybe this tenant doesn't require this many environments, and you're able to either go back a step and remove that tenant, or even just redefine your environment selection here again as well. And we give you this nifty toggle. For example, if the number of environments goes past 3, again, we hide it just to make the data neat and make sure that visibly it looks very neat as well. But if you just want to see more, you're able to obviously click this and see more, essentially. Cool. So that's where you connect all of your environments. And once I hit connect, you'll see that this is also something that we've built to make sure that it's really fast. And so hopefully you'll see it today, that I'm now connecting 272 tenants to this project. And as you can see, what we do is we give you a little loading bar here, just to show you the progress that we're making. And already, as you can see, we've connected 30 tenants, 50 tenants in, I'm not sure how many seconds has passed, but, we probably just hit 10 seconds or 12 seconds. So, 10 seconds for about, 50, 60 tenants. It's really good. And as you can see, we're slowly going through it. And it should be done. I'm going to try to time it right about. I'm not timing it correctly. But as you can see, my mistiming aside, it's going through it pretty quickly. And again, as mentioned, before having this bulk action, what you have to do was to, go into one, select all the environments that you wanted to connect to it, connect that, get out of it, go into another tenant, connect that project up. And so, that would take you vastly a much longer time than what this bulk action is currently doing. As you can see, we're almost done with it. So hopefully my timing will now make sense. And we are done. There you go. So 272 tenants connected to the SHIPPED23 project. I'm going to say that took about a minute. So that's pretty fast in terms of how that's done. And again, like a lot of our customers that do want to onboard this many tenants or even more than these tenants have said that this has really helped them save time in terms of the tenants that they're onboarding. So that's the bulk action of connecting, a project to multiple tenants. What I want to showcase now is the other way around. So actually connecting a tenant to multiple projects. So for example, here, what I've created is a SHIPPED23 tenant. And as you can see, we are connected to one project because we just did the bulk action to connect all those tenants to that project. But let's say for this SHIPPED23 tenant, I'm like, you know what? This tenant is associated with all these different projects, and I want to be able to connect to those projects. So again, as you can see, same window, same sort of filters that you have here, except the difference here is that instead of tenant tags, you're able to filter by project group or the lifecycle that the project is associated with. And again, you can select, the specific projects that you might want to connect to that tenant, or if it's associated with all these projects, you're able to sort of do that as well. Hit next. Again, you can associate all the environments that you want to with this tenant. And what you'll see here is that this is probably also very, very fast. So blink and you miss it so fast. So for example, I'll connect 15 projects. And that's it. It's actually connected to all of the projects. So it's incredibly fast both ways. And again, a lot of the goal that we're trying to achieve here is that, when you're onboarding onto multi-tenancy for the first time, or let's say you're already using multi-tenancy and you have a new project or a bunch of new tenants that you just signed up to your company, you really don't want to be wasting a lot of time with the administrative tasks. So obviously this is sort of admin to sort of connect them up, to associate it with the environments. And again, when you're using tenants at scale, this can take a long time in order to get right and to make sure like the connection exists. But using these new bulk actions and the speed at which we're able to connect tenant to multiple projects and a project to multiple tenants, you're able to just seamlessly get through the onboarding process, or get through connecting all of these tenants to projects to tenants, and really then go back to focusing on what you really care about, which is defining that deployment process and making sure like the releases go out on time for your tenants from the associated projects. So that's the bulk actions that we've released this year as well for multi-tenancy. And I'll swap back into the slides in order to present the final feature that we've released for multi-tenancy this year. And that is bulk deployments. Cool. And again, this is a snapshot of what the old deployment process looked like. So when it came to multi-tenancy, one of the pains that a lot of our customers were having was that, in between sort of like defining your deployment process to creating your deployments to, actually the deployments kicking off and actually being deployed to your tenants, that it took quite a while. So for example, here, as you can see in the screenshot, this was when we were testing out, the pain point that we heard, and this is creating 49 deployments. And just creating 49 deployments, and these were singular deployments to singular tenants. So this is basically 49 tenants that we're deploying to. That it took maybe 5, 10, 15, maybe up to 20 minutes just for this progress bar to soft load. And again, this is just for 49 tenants. As you recall, I'm already saying that we have customers that are using hundreds, thousands, 2,000s, 3,000s of tenants on Octopus. So this process was really, really slow. It really, really slowed down sort of like a lot of the the quick and easy sort of deployments that folks wanted to do. So for example, let's say you try to just deploy hotfix or a patch. Imagine having to wait sort of 20 minutes just to get through 49 deployments in order to do that. So it took a really, really long time to do that. And again, it's just unacceptable when we're talking about being able to deploy to tenants at scale and making sure that you're able to kick off those deployments pretty easily. And so the way that we solve that is using our bulk deployment feature, where instead of waiting 20 minutes for 49 deployments to kick off, it actually just happens immediately. And the speed of it is I think would probably scare a lot of you, but hopefully scare a lot of you in a good way in terms of how fast it actually happens. So we'll flick back over into the demo instance, and I'll show you what that looks like. So here we see that we're deploying a release. And so, for example, let's just say I select development here, and we'll go for a tenanted deployment. And I'll select a couple tenants to deploy to via tenant tag. So for example, I'll select the Western tenant tag, and we can see that there are, again, 49 tenants that we are going to deploy here. So remember what I said, that when we were testing this ourselves, just kicking off 49 deployments to these tenants, would take 10, 15, 20 minutes to just complete through that progress bar. And that progress bar does nothing. It's just progress, and then after that, does the deployments kick off. So what I'm going to show you now is that there is no progress bar. It just kicks off. And that's because of the new bulk deployment feature. So what we've done is that we've grouped all the tasks together into a single task, and that just helps to really speed up the whole sort of deployment process. So I'm going to hit deploy. And that's it. It actually just goes through. And hopefully this isn't this is a more like last but not least sort of feature, but it's really, really crucial that we're able to get to this stage as quickly as possible and not be stopped at a progress bar even before we get to deploying to all these tenants. And yeah, as you can see, it's just gone through. Well, it's actually completed. And that's in contrast with having to wait for this progress bar to fill up, to complete, to be like, hey, all right, this progress bar is done, and then we kick off the deployments. It just goes straight into the deployments. You're able to kick it all off, and it's already completed by the time even before I finished my explanation of it. So again, a lot of what we were trying to solve here is really speed to deployment, making sure that folks are able to get to what they need to in terms of deploying to their tenants in a timely manner, and removing friction points in that journey where they don't want to be waiting around, especially when imagine you had a hotfix to fix a really crucial bug, and you're stuck at that loading screen for 15-20 minutes at a time. I think that's probably not something that anyone wants to go through, and you want to be able to kick off those deployments solved immediately. So again, this just really showcases sort of like the speed at which you can do your tenanted deployments. And obviously I've only shown 49 here, but we've had conversations with customers or even internally within the company where folks have been deploying to 200, 300, 400, even 1,000 tenants, and the same speed exists as well. So again, speed to deployment, speed to getting the things that you want to get out to your tenants as quickly as you can. That's all achievable now with our new bulk deployments feature. Awesome. So I'll flip back over to the slides for a couple of concluding statements. So yeah, that's all. That's the whole presentation today. So really, really thank you. Thank you for coming over to SHIPPED23. Thank you for listening to what I had to chat about in terms of multi-tenancy and all the new things that the team has done this year. I feel that we've really hit the ground running and really achieved great goals. And if you want to learn more about multi-tenancy, please feel free to visit our use case page at octopus.com/features/tenants. Until next time, I'll see you then, and have a great rest of SHIPPED23 to look forward to.
Hello, thank you for joining me for a look at DORA, DevOps and deployments. I'd like to share some ideas that are informed by some practical experience of using theoretical frameworks and of applying research to software engineering in real life. A rough outline for today's session is that we're going to take a look at DORA, and the research work they've been doing for almost a decade. We're also going to think about whether DevOps means the same thing in 2023 that it meant back in 2008, which was when Patrick Dubois presented his session at Agile Toronto, and that foreshadowed the creation of DevOps Days. We'll then talk about culture and how you can change it even when you're not the boss. I'll also close with a look at metrics and share how Octopus customers have access to some cool insights that can help inform your continuous improvement journey. But that's enough about all these other people. What about me? My name's Steve Fenton, and I'm a technical content creator at Octopus Deploy. I'm joining you today from Basingstoke in the UK. I'm really honoured to be able to share some ideas with you today. Previously, I've been a software engineer, a development manager, and a director of product and development. I've worked in quite a few industries, including automotive, finance, technology, but perhaps most crucially, it was when I worked in healthcare. In most places, you can diffuse the tension by saying, what's the worst that could happen, or nobody's going to die. But we were providing emergency triage and possibly dispatching ambulances, so there was a very real possibility that lives were at risk. The process we developed and the automation we introduced was designed to give us really high confidence in the safety of the software we were building, but we found something else. It also allowed us to iterate quickly because everyone who needed to be involved in the development of the software, including our product manager, who was a clinically trained nurse, was on the same team. This was the kind of team the DevOps movement was talking about. Patrick Dubois says DevOps is about removing the friction between silos, and all the rest is engineering. So we should create truly cross-functional teams, and everyone who's needed to make things happen should be on that team. We should also carefully manage the dependencies and interactions between different teams. We need to pivot away from functional silos to something more cross-functional, with minimal, carefully managed dependencies. Patrick also said during that 2008 conference talk that we should deploy often, not just the application, but the database and the infrastructure. So has this idea changed, and if so, how? The big change in how we think about DevOps and software delivery has come from DORA. DevOps Research and Assessment. Everyone forgets the A, it's for assessment, so they've added a little banner to their logo to help us all out. You might have heard of DORA through the amazing book Accelerate by Dr. Nicole Forsgren, Jez Humble, and Gene Kim. Or you might have heard of them through the Accelerate State of DevOps report, which Octopus is proud to sponsor. For the past year or so, the DORA team has also been letting us get an inside view through the DORA community. The community meetups tackle questions about putting all these insights into practice across many different kinds of organizations. Using a lean coffee format where everyone can suggest topics and add their thoughts to the conversation, we get to hear diverse perspectives about how to apply the research in the real world. Now, over the years, the state of DevOps research has helped us understand our industry better than ever. We've now got concrete ideas about what practices are needed for DevOps, what collaboration really looks like, and how we can help organizations to be more successful. So let's take a look at these concrete things. This is the DORA core model. It doesn't contain everything they found in the research, just the items with the highest confidence, but that makes it a lot smaller and more manageable. It's a capability model, and that means that each of these boxes is a capability, which is a fancy way of saying a thing you can do. Before DevOps came along, the agile software movement had lots of different ways you could work and things you can do, and they were based on experience. This was often called empirical observation. People shared what worked for them. The research confirmed some of these things. You'll recognize some of the capabilities in this list have come from extreme programming and continuous delivery. In fact, continuous delivery is one of these boxes. Both of the authors of the continuous delivery book, Jez Humble and Dave Farley, have been involved in the research over the years. There's a lot of good stuff you can use from this model. The research says doing the things on the left makes it more likely you'll get the things on the right. You get the green box, which is near the middle, and that says how well you can deliver software. But you also get those blue boxes on the right, which are even more important. Who doesn't want less deployment pain, less rework, and less burnout? Crucially, organizations that work in a way that's consistent with this model perform better against their goals, and that's things like revenue and market share, changing the world, or even taking over the world if that's what they've decided they want to do. Whatever commercial and non-commercial goals they have, they're more likely to achieve them if they use this model. One of the things on this list is particularly important. It's the one called generative organizational culture, and we'll be coming back to that shortly. Before that, though, you can find out more about the research at dora.dev, and you can join the discussion with the research team and other practitioners at dora.community. So let's get back to this thing called generative culture. Where did this grand-sounding name come from? A chap called Rod Westrom studied culture in safety-critical industries. He found there were 3 types of culture: generative, bureaucratic, and pathological. Here are the cultures in their detective form. Jessica Fletcher is your generative culture. She's high trust and low blame, as long as you don't kill someone. People share concerns and take action to stop problems before they happen. Near misses are opportunities to learn. This is the ideal DevOps culture. Hercule Poirot is a bureaucratic culture. Everything is subverted to the agreed procedures. Things have to be arranged carefully. You must fill in the right forms. Mistakes are investigated and controls are brought in to try and prevent them from happening again. The problem with bureaucratic cultures is the actions they take to make things better often make things worse. If a deployment fails, they introduce change advisory boards and increase the weight of their approval process. This slows things down and it increases batch size, and this means performance ends up getting worse. Sherlock Holmes is a pathological culture. Big personalities rule at the expense of team success. There's a lack of cooperation. People don't want feedback. Nobody wants to take responsibility for anything. When something goes wrong, someone's going to get it, and it doesn't matter too much who. The problem with pathological cultures is that everyone is wasting time covering themselves. You have to collect evidence of everything, and you use this when things go wrong. Nobody's really your friend or your colleague when the axe is swinging. It's everyone for themselves. Because you can't talk about near misses or failures, it's not really possible to improve anything. So how are we supposed to fix our culture if it's got problems? The answer is we do it with actions. You have to act your way to a new way of thinking. Nathan Harvey said this during one of the DORA community meetups recently. You've probably worked somewhere that started a cultural transformation project. They come with a big internal marketing campaign and they have slogans on pens and posters on the walls. I worked at a company that had a quality problem, so they ran Project RON. They said, do it right, do it once, do it now. And the posters had that written and it spelled out the word RON. But nothing changes when people talk about culture. You can put up inspirational quotes and you can put up posters, but the only impact is that your facilities department says you should have used blue tack and not sellotape on the walls. The one thing that you can do that works like a lever on culture is to take action. Now, more specifically, if you're on a development team, you have to make some local changes that will then spread beyond your borders. We're going to look at how this cycle of cultural change can work, using the DORA core model as a source of inspiration. We call this the capability culture cycle because you use the capabilities to create an environment where change is possible. There are 4 stages, so I'm going to pick a random stage to start with. I'm choosing stage 1. As a technical team, you can improve your pipeline. The book on continuous delivery by Dave Farley and Jez Humble describes this pipeline. It includes everything that happens from the moment you check in on a change right through to that change making it to production. So this is things like your code review process, your build, your test automation, packaging your application, setting up infrastructure, and deployments through all of your environments. This is the production line that exists within your software delivery process. Everything that happens before that commit is part of the creative design process, where humans are using their ingenuity to create something valuable. But once the change enters the pipeline, it should all be conveyor belts and robots. There shouldn't be any manual handling here. Everything needs to be automated, repeatable, and reliable. But this is a long list of things, and it's definitely too much to do in one go. You have to narrow it down and pick one thing, some part of this pipeline that's slowing you down, something that you can do that will bring you a solid win. That's where we go and get our high quality, large format, laminated DORA core model. Yep, it's this slide again. I'm going to show it again later on too, because I've found it so useful. You might use this as part of your existing retrospective or a continuous improvement process. It's a source of ideas of things that you can do that are statistically likely to lead to good outcomes. Most of these capabilities need some practice, and you might not see the benefits until they become fluid and familiar. But at least you know there's evidence in the wild that shows they do work. Each item in this diagram that has a line lifted pointing towards software delivery performance is one of the possible things you can do as part of the first step in this capability culture cycle. What will move the needle and make things more reliable, more repeatable, and more secure? Maybe this one, deployment automation. There's something about this one I like a lot. I'm joking, of course, but in all seriousness, this is never a bad place to start. You spend some time up front automating your deployments, and then you win that time back every week forever. That makes it self-funding. When I've been brought into an organization to help with their software delivery, I first check they have basics, things like version control. There are still some teams that don't use it, so we make sure those scary situations are dealt with quickly. But after that, I'm always adding the same things: test automation, deployment automation, and observability, which includes monitoring and alerting. Over the past 10 years, these are usually the crucial missing pieces, and teams are wasting time and energy handling these things manually and handling them late in the process. In the worst cases, customers are handling the testing and observability rather than the organization, and that's not ideal. These might not be the gaps in your team. The great thing about this capability model is it doesn't assume to know your context. You're better placed than anyone to apply the model. You know what problems you have and what your organization is trying to do. So you take what you know and you look through the model to find inspiration. When you find a capability that you think will help, you select it, practice at it until you can do it well, and then see what it does to improve your ability to deliver software. A simple way to tell if it is working is the 4 software delivery performance metrics. They're in the green box just off to the side here on the model. The metrics give you a balanced way to understand what good software delivery looks like, and we'll come back to metrics shortly. So you've done something to improve your delivery. What happens next in the cycle? After 1 or maybe 2 changes, when you can see your performance is improving and your confidence in your ability to execute is heading up, you should be able to reduce the size of your batches. When your pipeline is slow, you tend to collect lots of things before pushing them through the painful process that gets them into production. But if the pipeline's fast, you should be able to use it more often. By running your pipeline more often, there'll be fewer work items in that batch that's being deployed. Now, this has quite a dramatic impact on risk and complexity. You'll catch problems sooner, and it's much easier to link issues to their original cause. You won't find valuable work getting delayed by problems that are caused by all of the other changes in the batch, which is a really common problem when you have large batches. Most importantly, you'll be able to show your changes sooner, which means you can get feedback that will influence what you work on next. Instead of continuing with a bad plan, you can change the plan based on what users are telling you about the work you've delivered to them, either directly or through some system of measurement. For example, if you intended to decrease abandoned shopping baskets, but your changes increase the abandon rates, you can revert the change and think of a different way of solving the problem. It puts a stop loss on the amount of money you waste developing features when it turns out they aren't useful or valuable. But in terms of changing culture, it also means you can build trust. When you look at the more depressing software development frameworks, you'll find that they all share one thing: they're really heavy. Lots of tasks have been added to the process in an attempt to control what software teams are doing. There are checks and balances, signatures, and documents whose only purpose is to indemnify someone in the highly likely event that the project will be a disaster. The reason for this heavyweight process is the organization doesn't trust the development team. What's worse is that the process actually makes the team look worse. And that further justifies increasing the amount of process to try and control it. It's a cycle of infantilization of what should be a professional industry. But when people in your organization can see that you can execute well, they start to relax. This is what you want to prove. The software and the business is safe in your hands. Demonstrating your ability to execute is what shows people in your organization you're a professional software engineer. So as you iterate on these first 2 steps, you'll continue to build trust. And this is a crucial investment that I like to call the trust fund. When your trust fund has a healthy balance, you can move to stage 4. Stage 4 is where you ask the business to move with you. You've taken actions to demonstrate your ability to do great work. The business can see the results. Now you ask them to relax a constraint. They can remove a barrier, do something to make your life easier so you can perform even better. This is where you might ask them to simplify the change approval process if it's too heavy, or increase their investment in tools, or open up production deployments to a wider group instead of a single gatekeeper. In our Octopus survey, we found having a single gatekeeper for production deployments limited the benefits of automation, because the constraining factor for the team's performance was getting past the gatekeeper. It didn't matter if deployments took 5 minutes or 5 days, they'd be waiting longer than that to get the sign-off. You can download the Octopus survey report from our website at octopus.com. The state of DevOps research also tells us that streamlined change approvals increase software delivery performance, and they make a positive impact on well-being too. So this is your opportunity to get something in return for all of your work improving the pipeline. You've moved, and now it's time to ask the business to move with you. With the capability culture cycle, instead of asking for a generative culture, you're going to grow it. By increasing your skill in these capabilities, these things you can do, you increase the balance of your trust fund, and that enables and encourages change to the wider culture. What you ask for will depend on your context, but ask for something that's going to give you another chance to repeat the cycle so you can show what happens when you work with the business to collaborate on improved software delivery. Use the 4 metrics to track progress and to bring a curiosity to what you do that will take you past doing things how they've always been done. When choosing a capability to explore or your next ask of the business, base it on the pain points that you identify in your retrospectives or in your other continuous improvement processes. Before long, both the business and the technical people will be showing all the signs of joy. Look how happy the detectives are now. And I can confirm that that is what Sherlock looks like when he's delighted. So we fixed our culture, right? Well, not exactly. What we've created with this cycle is a culture bubble. A part of your organization is now a better place to work, but it might still be surrounded by business units with different cultures. It's possible to keep expanding this bubble, but you might not be able to transform your whole organization this way. You really need the top leaders in your organization to be actively working on culture if you want to make a sustained change. If those leaders don't support it, then it may be a generational issue. Those leaders would have to move on or retire before you can expand that bubble and make things permanent. And the longer the culture has survived, the more it will resist change. If your local leaders support the change, but leaders elsewhere in the organization don't share the same values, you end up creating what Will Larson calls a values oasis. That means the cultural bubble won't survive a change in leadership, and the team might not be prepared for what happens when their leaders leave. If you've ever led a team that all left the organization soon after you did, you probably created a values oasis. It feels like the right thing to do at the time, and I've certainly done it before I knew what a values oasis was, but it isn't always the best thing for the people on the team. None of this means the bubble isn't valuable. Everyone on the inside of the bubble is doing great work, and there's less burnout. It's making a genuine difference for a whole lot of people. Maybe that's enough reason to persevere, but make sure people understand the limitations of this bubble so they don't get a nasty surprise later on. A common problem with a values oasis is that the technical capabilities that you introduce aren't sticky. If the champions move on, the practices that they brought in start to slide. So you might find it helpful to share with the team what a values oasis is so that they understand those limitations and they understand that those practices won't stick unless they also support them. So I think on balance, we have a useful concept with the cultural bubble. It may not be perfect, but it's definitely making things better. If you can get enough traction by demonstrating the benefits to leaders, you'll increase the number of people who benefit. To really spread the joy, we need to convince our leaders of this. So that's where measurements come in. The capability cultural cycle benefits from measurement because what you measure will help you improve your execution and build up your trust fund. Metrics help you understand whether all your hard work is paying off. They also help other folks in the business understand the value of the work you're doing. It doesn't answer the question, are we there yet? Because continuous improvement doesn't really have an end state, but it does answer the question, are we pointing in the right direction? The real things we're interested in impacting are the things on the right, organizational performance and well-being. These are the true measures of success, but they tend to be a lagging indicator, which means they're not as useful to your continuous improvement process. When you try out a change, you need to know sooner whether it might be working or not. And that's why software delivery performance can be so useful. The numbers are easy to obtain, and when you make changes, they respond sooner. Once software delivery performance moves, you'll see the outcome metrics moving later on. When it comes to tracking your ability to execute, the 4 software delivery performance metrics can be a really good guide. They measure performance in a way that relates to the broader success of the organization, rather than the traditional software metrics that you may have seen on legacy projects. If you improve these 4 metrics, you're likely to increase the balance in your trust fund, and you're likely to help the organization hit its goals. At Octopus, we wanted to help you with these metrics. We might not be able to see your whole pipeline, but we have a view of a crucial part of it. So based on your deployments, we can provide you with a set of insights. Deployment insights shows you a representation of those 4 key metrics, plus a bonus one that's really relevant to your improvement process. The tempo metrics include deployment frequency and deployment lead time. And the stability metrics show the rate of failed deployments and how long it takes to recover after a failed deployment. You can also track the duration of deployments, which means you can detect when deployments are taking too long and take action to reduce the time it takes. You can drill into all of the data and the trends, find outliers, and see recent entries. So, when you're applying the capability culture cycle, these metrics will guide your improvements and help you add to your trust fund, and that's pure gold. Deployment Insights in Octopus lets you inform your improvement efforts and detect when things are slipping. The dashboards can motivate you to do many of the things that will improve how you work. Smaller batches, frequent deployments, and short lead times will help you improve all of these metrics. I find it particularly useful to drill into the detail in these reports to understand why the charts look like they do. The screenshots here are from web projects that I actively work on. You can see we've made dramatic improvements to the deployment lead times, but even the slight problem emerging where lead times are starting to head back up for one of the projects. This is great stuff. We can look at why that is and take some action. Let's quickly check what we've covered today. We've had a look at Dora and their research. Turns out they did quite a lot for us. Thanks, Dora. You can find more information at dora.dev and join the discussion at dora.community. We also looked at how our understanding of DevOps has changed thanks to this huge research program. We then looked at the impact our actions can have, creating the right conditions for culture to change. And for tracking our improvements, we looked at the Octopus Insights dashboard, which will give us an idea of where we should focus our efforts. Thanks for listening. I hope there was something useful for you in the session, and I hope you enjoy the rest of SHIP23.
Hi, everyone. Thank you for joining me today. My name is Bob Walker. I'm the Field CTO at Octopus Deploy, and today I'm excited to talk to you about multi-tenancy architecture lessons learned. Now, before we get started, just a couple of things. If you're interested in getting in touch with me after this talk, please feel free to reach out to me. Any of my contact information is down below on this slide. And one thing you might notice is that I have been with Octopus Deploy since 2018. Now, prior to joining Octopus Deploy, I was in fact an Octopus Deploy customer. I've been a .NET developer since the very early days of .NET, and in fact, my very first job was converting classic ASP pages over to ASP.NET web applications. Now, one of the more interesting things about my career is that every company that I've worked for has done multi-tenancy in some form or fashion. Even a company like Farm Credit Services of America, you wouldn't think would be a multi-tenanted application, but in fact it was. And my goal today is to take all of the information that I've gathered from working on all these various multi-tenanted systems and provide you with a set of guidelines and decision points and little lessons that I've learned along the way. And so in terms of an agenda for today, first we're going to talk about the different approaches that I've worked with. And then you can see the 3 different approaches, and we're going to go through each of those, and we're going to give each one kind of a rating based on a different set of criteria. And then finally, we're going to wrap it up with an evolution of multi-tenancy that's occurred over the last 10-ish years that has completely changed how I think about multi-tenancy. So first up, let's talk about the different approaches, along with some considerations that you need to start thinking about. When I talk about approaches, there are 3 common approaches that I've encountered a number of different times throughout my career, as well as helping Octopus Deploy customers. We have the single website and single database, and this is where everyone logs into the same website and all of their data is stored with everyone else's data. The evolution of that is the single website and multiple database. Everyone still continues to log into that single website, but when they do log in, they're given a different connection string based on the tenant that they're assigned to, which will then point them to the appropriate database. And then finally, we have isolated infrastructure. And you could easily replace virtual machine with Kubernetes namespace, but the point of this is that everyone gets their own sandbox, and everyone gets their own set of infrastructure, their own namespace, or whatever the case may be. The point is that they're isolated from one another. Now, when it comes to different considerations, I've put together a list of things that you should probably consider when you start architecting your own multi-tenant applications. The first one is going to be the tenant maintenance, or how long it will take to add, remove, or update a tenant, along with the underlying platform costs with managing the whole tenant maintenance. Next up, it's going to be code complexity. How much code is required to isolate tenants and users? That leads itself nicely into crosstalk, because this is a very big concern with a lot of different companies when you're concerned with whether or not a tenant can access another tenant's data. You also have the noisy neighbor effect, where one tenant can impact another tenant based on certain actions that they perform. Essentially, it means they consume all of their resources. We also have to consider deployment time, or how long a production deployment takes and when you can actually do the deployment. And then finally, we have contractual complexity, where we have different customer sign-off, data isolation, whatever the case may be when it comes to how you want to structure your contracts for your multi-tenanted applications. And what I've done is I've created a grading scale of low, medium, high, low being the best, high being the worst, and rated each of these different types of risks that you need to consider. And we're going to go through each one, so don't worry about trying to memorize this sheet. And you might be thinking, well, wow, single website, multiple database, that has the worst rating out of all of them. And you'll slowly see why I've come to loathe that. But there are pros and cons to each approach, and you need to be aware of all of those. Now, in terms of my own experience, I think the most interesting thing is that of all of the systems that I've worked on, the single website, multiple database, that's the one I have the most familiarity with. I was either a lead engineer, an architect, or principal architect in any one of those systems. So let's first talk about the single website and database. And again, this is where everyone will log into the same website, and all of the data is intermingled with everyone else's data. Now, in terms of tenant maintenance risk, it's rather low because really all you need to do is add a record to a table inside of the same database. All the business rules that you already have, they're already in that code base. There's not a whole lot of work you need to do. And in fact, you can even provide self-service for a number of your different customers. And it's probably going to be fairly simple to do because, again, all of those business rules and everything that you need to add the tenant are going to be right there. But that low tenant maintenance risk has a cost to it. And that's because your code complexity is going to be very, very, very high. Just think about every single query that you're going to add. If you have to access any sort of customer data, you need to make sure you have where tenant ID equals the tenant ID, or X, for every single query. So if you're taking an existing application and you're attempting to make it multi-tenanted, it's going to require a significant amount of effort to do that because you have to go through and update every single query. Now, I think one of the more interesting things about Octopus Deploy is in 2019, we added the concept of spaces. And for all intents and purposes, spaces walk and talk a lot like the single website, single database, multi-tenanted approach. And we did have to add where space ID equals the space ID for every single one of our queries. But on top of that, as we were going through this, we also realized, we need to change how users and teams are going to be assigned because we want to have the capability for users to be cross-space. And so then we had to go in and change our permissions model. And so the point of that is that you think it's just as simple, I just need to add a where tenant ID equals something to every single query, but it's going to slowly balloon from that, and it's going to make code complexity very, very, very high. And then you also have to worry about your authentication and authorization, because the last thing you want from that is having crosstalk. And this is where one tenant, again, can access another tenant's data. And one of the interesting things is that I've rated this as a medium, which sounds kind of insane when you think about it, because you could have a situation where you miss a query, or you did what I did when I was working on this application, and we were adding a feature for a very particular customer, and I didn't know the application very well, so I was just hard coding the tenant ID for every single one of the queries. 045, I actually remember that ID. I'll never forget that because I've probably entered it in thousands of times. And you also have to worry about security because users can get assigned to the wrong tenant, especially if the users are being managed by your own company or by your support personnel. It's very easy to make a simple mistake like that. And in terms of malicious users, it's also an avenue of attack. The good news is that this is typically found during testing. When we hard-coded that 045 for every one of our queries, I can't tell you the number of bugs that we got, but it was measured in the dozens within the first day because we only tested it for that one particular tenant. We never tested it for anything else. And so QA found all of those issues. We can also automate that. And this isn't a manual test. You shouldn't be manually testing all that, but you should automate a lot of that stuff. And if you do find any sort of issues, it's typically easier to fix, especially if you accidentally have a tenant write data to another tenant's system, because you really just need to go into the same database and update a couple of records. So really the remediation to this problem is why I've rated it as a risk of medium. But the noisy neighbor risk, that's rather high. This is because all the resources are shared across all of the other customers. And going back to that application that I worked on where we had all the users and all the database, we had one user that was for one of our bigger customers. They said, I want 5 years worth of data for this report. And so we started getting all of these support queries in saying half our users are reporting all kinds of timeout issues. And we dug into it and we realized, yeah, we had a user that was just asking for 5 years worth of data. One of our web servers was pegged in terms of memory and CPU, and the database was just trying to process as much data as possible. But one of the upsides to a single website and single database is that your deployment time is really low compared to everything else because you have one application and one database to update. And you can update everyone at once because, again, you just have to update that one application and database. And if you need to write any sort of database migration scripts, it's a single target. In fact, you could probably get a copy of the database or multiple copies of the database, remove any PII data, and start running and testing your migration scripts. And you know it's going to work. But the downside of that is the contractual complexity risk is high. Because if you have any sort of situation where tenants must sign off before production deployment, well, when you have a single website and single database, then you can only deploy as fast as the slowest tenant approves. And this happened to me quite frequently. It didn't matter how fast we were pushing changes up to our staging environment. Until everyone signed off and said, yes, this looks good, we couldn't deploy to production. And so we started looking at things like feature flags. Could we disable certain functionality for specific tenants until they sign off? But then we added additional complexity. On top of that, all of the data lives side by side with other tenants. And depending on the contract and the customers, this could be considered a high risk, and you might have to go through a lot of auditing and verification to make sure that one tenant can't access another tenant's data. So it's just a lot of extra work on top of that. Now, because of that extra work, this is typically where I see customers move into the single website, multiple database approach. And this is where you have, as it says on the tin, you have single website, and then every customer or every tenant, they get their own database. Now, in terms of tenant maintenance risk, it goes from a low to a medium because now you have to create a new database for every single time you add a new tenant. On top of that, you're probably going to have some sort of control system or control plane or connection string manager or whatever the case may be, and you need to add all the connection information about that new database to that connection manager. And unless you have any sort of automation in place, self-service becomes more of a pipe dream and you have to manually do all this work. Your code complexity risk, though, it drops from a high down to a medium because you no longer need to have customer-specific where clauses. But you are going to require a control database to manage all of the different databases and connection strings, or you could leverage secret stores, or there are a number of different approaches to handle this. The big thing to make note of is that it's going to require extra work to create that type of control database, and it needs to be perfect all the time for it to work. And if you have any sort of tenant differences, then you're going to also have to add feature flags as well, just like the single website, single database. There's no real way to get around that. Now, the crosstalk risk, I've rated this as high, which sounds, again, not quite right, but follow me for just a second. Because although every database is isolated from one another, the mechanism to authorize and authenticate users can still have bugs. The thing that stores the connection string and, say, the session for the user could have a bug. And this happened to me when I worked at a company where there was a bug in the core .NET Framework session management system where if the right conditions were met, a user was assigned the wrong connection string. It was pulling the wrong session information. And we didn't even know about this. We didn't even hear about this until someone called us up and said, hey, why do I see this data for this particular customer? They're not even in our region. How is this even possible? It is very insidious to find when it happens. because it's going to occur inside of the runtime with little warning, and it's going to be much harder to test and isolate. And then once you figure out what's going to happen, fixing it could take quite a bit of time. When you want to fix the data, then you also have to worry about how am I going to move the data from one database to another, because you have to worry about foreign keys. Do you have all of the data? How are you going to clean up the other data? So when we found this particular issue, it took us well north of 2 weeks to finally clean up everything. So again, it was very, very insidious to find. And this is very different than, say, the single website, single database, where it will happen, but you can probably test a number of different scenarios to prevent that from ever happening again. And if you do encounter it, it's much easier to fix. The noisy neighbor risk, it drops from a high down to a medium. And this is primarily because everyone has their own isolated DB resources, especially if you're doing a managed provider such as Azure SQL, where you can say this database can have this many DTUs, for example. But tenants, they still share the CPU and RAM resources. So if the web server is being consumed, for example, you're processing 5 years worth of data, well, there's not a whole lot that you can do about that. And you can still have that user decide to consume everything. Now, the deployment time risk, this is high. And the reason I've rated this as high is because imagine if you had to update hundreds or thousands of tenants. Well, you need to update all of those tenants' databases at the exact same time because they're going to be running on the same code base. And even if each deployment took 30 seconds and you had 120 databases, you're looking at 60 minutes to handle that deployment. Now you can multi-thread it, but again, you're still talking 10 minutes, 30 minutes, an hour, depending on how many databases you need to update. And so you're going to have to find a situation where no one is accessing the system at any given point in time. You're going to have to look through your logs and go, okay, well, 5 a.m. Sunday is going to be likely the best deployment time because no one's using it for 2 hours. So the amount of traffic that we get is so low, it doesn't really matter. And so this is how I ended up in situations where I had to wake up 5 a.m. Sunday to do a deployment or 2 a.m. Saturday to do a deployment. It's because we had to update these databases. It just took so long, and our outage window was so high because of this. Now, the contractual complexity, this drops from a high down to a medium. And the primary reason behind this is because the data is isolated from other tenants. But if you have other rules in place, for example, sign-off, you still have to wait for the majority of customers to sign off before you deploy. And again, you might have to add feature flags for those particular holdouts. Now, let's move on to isolated infrastructure, because this is almost the exact opposite of single website, single database. And this is where, again, everyone gets their own sandbox. And we have the screenshot showing virtual machine. So imagine everyone gets their own EC2 instance, or you could do a Kubernetes namespace. But the point, again, is everyone gets their own sandbox. The downside to this approach is that adding new tenants, it is very high. It costs a lot to do that because you have to create new infrastructure for each tenant. And so adding a new tenant, unless you have automation, could take easily 10 plus minutes. I wouldn't be surprised if you could measure it in 20 or 30 or 40 minute increments. And if you want to have any sort of luck in doing this and being able to scale this out, you're going to need a separate platform or a separate application with automation to add a tenant. And this is what we had to do for Octopus Cloud. Because Octopus Cloud, every customer, they get their own Kubernetes namespace, they get their own Azure SQL database, they get their own Azure file storage. And so we needed infrastructure as code to be able to scale up that additional resources, but also destroy those resources if it was a trial customer and they opted not to purchase the product. And so we built the cloud platform to manage a lot of this stuff. We have a cloud portal. It's an internal system that's used to manage our Octopus Cloud instances. And without that, there is no way we could be adding hundreds of different customers a week, if not more. The good news is that your code complexity, it's the lowest of all three of these options because you're not going to have any customer-specific where clauses. You don't need to have a control center where you manage all these different database connection strings that your application has to manage. It's just a single setting for each tenant. And again, you can make an existing application multi-tenanted. You will still need to have feature flag for tenant differences, because if you don't, then there's this temptation in place to fork the code base per customer or per tenant. And I've worked on a couple of applications where that was the case, where the decision was made before I arrived to fork the application. And so every customer, they had their own copy of it, except for maybe a handful of customers where they managed to consolidate them down. This just makes your code complexity go from a low to extra high, because now you have to manage all these different code bases. The good news is with this approach, your crosstalk risk is low because everyone has their own isolated infrastructure. There's not a single place within the product code base to access all the tenants. You don't have that connection control manager. You don't have all the business logic inside of there. That's typically managed by a separate system. And so the chance of one person getting access to all of the credentials for all of the different systems is very, very low compared to the other approaches. So if one tenant is compromised, it only impacts that one tenant. And it's unlikely that one tenant is going to magically connect to another tenant's system from their virtual machine, because they'll never have that access. They won't even be aware that that's possible. Your noisy neighbor risk is also really low, because each tenant is provided with their own dedicated resources. And if one tenant decides to consume all of their resources, that's going to have almost no impact on all the other tenants. Now, all the tenants or all the users for that one tenant that's consuming all the resources, they'll probably have some words to say to that one user, but that's more of an internal problem at that point. Now, the deployment time risk, this is more of a medium. It's not a high. And the big reason is because generally deploying to each tenant is going to be typically pretty fast. And you can do more of a rolling deployment. You can schedule the deployment for when the tenant is not using the system. And so you can look at each individual tenant's usage and go, okay, at this particular point in time, that's when we can do our deployment. So we can do a rolling deployment across it. And this is typically how we do Octopus Cloud deployments. Customers specify the maintenance window, and during that maintenance window, we'll perform the upgrade. And every customer is going to have a different maintenance window throughout the day, and so it's just a rolling upgrade to get everyone upgraded. Now, the contractual complexity risk is also rather low because we can deploy to each tenant as they sign off on the changes. If they haven't signed off, you just don't deploy the latest code fix to them. You really don't need to add any extra feature flags to hide functionality because they haven't signed off. And because everyone gets their own sandbox, data is completely isolated. So I want to wrap this up with kind of a discussion around the evolution that's occurred in terms of what's possible with multi-tenancy versus when I first started my career versus where it is now. Now, if we look at these three approaches and we see these different ratings, one thing that might surprise you that if you asked me 10 years ago, I probably would have picked the single website multiple database or the single website single database. Most likely, I probably would have picked the middle one. And this is because that's what I knew. But it's also because I had a very much a self-managed data center way of thinking. I'm like, oh, how are we going to stand up all those new web servers? Now, the database server, we have so much resource. We can certainly add a lot of databases to that. But gosh, I don't think we'll be able to add a lot of new web servers to this. But today, if you were to ask me, I would pick isolated infrastructure as my default approach, unless there were some compelling reasons not to. And the big reason behind this is you got to think about what's available today versus even 10 years ago. We have all the cloud providers such as AWS, GCP, and Azure. We have infrastructure as code that enables creating and destroying resources that we've never had before. Adding a new namespace, adding a new virtual machine, adding a new database. We can codify that and we can just apply a Terraform script or run a CloudFormation template or anything along those lines. We also have tools and technology that we haven't had before, such as serverless computing with Azure Functions and AWS Lambda. And if we still want to use virtual machines, that's perfectly okay. With Azure VMs and Amazon EC2 instance, we get that. But we also have containerization, and that's really, in my mind, changed the game in terms of multi-tenancy. Because we no longer have to have every customer gets their own VM. They get their own container. They can get their own container and their own namespace. And so adding a new namespace is a fairly trivial thing to do. And spinning up that container, Kubernetes can handle scale at an unprecedented level. But if you do go down this path, it's very critical that you invest in the underlying tenant management platform. You have to build, in my eyes, you have to build your own Octopus Deploy cloud. You have to build that cloud portal to manage your infrastructure, to know when your customers are doing, to know what versions they're on, whatever the case may be. You have to make that investment. Because if you don't make that investment, that approach is going to die on the vine, and people are going to go, how can we have a single website in multiple database, or how can we put everyone in the same website, same database? But it's also important to recognize that not all use cases are the same. Some questions that you need to ask yourself. Where should the multi-tenancy complexity live? Should that exist in your code base, or should that exist in a separate application and inside of your infrastructure? What external restrictions do you have? I've talked about contractual restrictions, but there's also going to be data sovereignty restrictions that you also need to think about. We hear certain things where data at rest can't leave a specific country, for example. And I also have on there application host location. Sometimes a tenant could be a branch office. It could be a bank. It could be a hospital. It could be a retail location. Well, every single one of those is a separate tenant, and they have their own infrastructure. Well, you basically have created your isolated infrastructure. You don't really have a choice as to the approach that you want to take. And then one other thing to ask is, what do you want for adding a new tenant? Should your customers be able to self-service? Where are you today? And then where do you want to be to or get to? I want to wrap this up with just one final thought, which is, after working on the single website, multiple database, I would highly encourage everyone to avoid that, because ultimately it's the worst of both worlds. When you look at the isolated infrastructure, you still have to build a tenant management system to be able to spin up and down those new databases. But you also have to target multiple databases for your migration scripts, for example. But you get the very long deployment times in one outage window because you have all of those databases that you need to update. And you also get the downsides of the single website and single database, because you're going to need to add all those feature flags. You're going to have noisy neighbors. If you have to have sign-offs, it's going to slow down your deployments. But crosstalk is even more insidious and harder to test for, because now you have to worry about the different connection strings to the different databases. So thank you very much for watching my presentation. I greatly appreciate your time, and have a great rest of your day.
Hey, you made it to the end. Congratulations. What an event. 12 people from Octopus, 9 presentations, hundreds and hundreds of people who registered this event. Congratulations. We made it to the end, Gemma. What an amazing event.
Yeah, it's been great to have you all. We've covered some great content this afternoon, evening, morning, wherever you're watching from. So it's been great to have so many of you with us, but don't let this be goodbye. You can always reach out to us on all of our social media channels. We're on LinkedIn, we're on Twitter or X, whatever you decide to call it. We are on Slack, so please join the Octopus community and get involved. We'd love to speak to you further.
Yes, and so on behalf of Gemma and all of the other folks at Octopus Deploy, thank you again. We really appreciate you for joining us for our first ever event that we've hosted here at Octopus Deploy. And we look forward to seeing you at SHIPPED23, which will soon be announced.
You are literally all a part of history.
Excellent. Well, take care, and we'll see you online.
Bye.